Hello and welcome to yet another WeAreDevelopers Live Day. This time we're going to talk about Java. I'm Chris Hyman. I'm the VP of Developer Relations at WeAreDevelopers, and I'm going to be moderating the day. The first thing you saw here is a code of conduct. We have a code of conduct, which means basically if you are doing any isms, racism, sexism, these kind of things, we will cut you out and we will also follow it up. We make sure that this is a space where everybody can feel safe. So use the communication channels that we have wisely and be nice to each other and make sure that what you think might be funny is actually funny and not as on the expense of somebody else. So following up on that, it's just a matter of like behaving the right way. And I hope you all do. But that brings me to the first thing. This is a live interactive thing on the internet. All the presenters are going to show you their presentations, but you can use, I guess, on this side, you can use the comments here to ask questions. And please ask questions because all I know about Java is that it's actually coffee. And this is from Costa Rica. It's not even Java either. The other thing is I'm fostering a dog at the moment. So if there's a howling in the background, it's not our engineers. It's actually just a dog because she wants to get out. But she's on topics because she's a setter. So that's actually fitting as well. Which brings me to the first speaker that knows about Java rather than just rambling on like I do. And that is Jens Happe. And he's from Chrono24, which is a marketplace for watches. And he's going to talk to us all about scaling one server to millions of users. So hopefully there will be something for you to scale your server. And I wish all of you millions of users. So there's hopefully some good findings in there as well. Jens, how are you doing?
I'm doing great. It's great to be here. Thank you, Chris. How are you?
Okay. Are you ready to rock? Are you ready to tell people all about it? Okay, then let's get started.
Okay, as Chris told you, the title is Single Server Global Reach, and I'm going to talk about today about like where we are, how we developed our system to scale to millions of users, and to actually fight complexity along the way. Because when I prepared this talk, I thought, okay, this is going to be a very technical thing. I talk about our architecture and all the things that we did to make this work. I will do that, but not so much as I thought, because I realized on the way that most of it is about, hey, what are our guiding principles? What is our coding culture? How do we approach things? And that actually made it possible to keep complexity down and build a system that actually scales, as Chris said, to millions of users on, theoretically, a single server. So let's just go into it. Just before I start, a few facts about Chrono24. As Chris already said, it's a marketplace. That means we have seller-side people who want to sell watches online can do that on Chrono24. There can be private sellers, so people like us, normal people who own a luxury watch for whatever reason, or professional sellers who are in the business for a long time and do that professionally. So that's what we do. And usually I'd love to ask people when I sort of meet new colleagues for the first time or during an interview, what do you guess, how many users do we actually have on our platform on a monthly basis? And now Chris spoiled that already, so it's a bit tougher now. But usually the answer I get is about, it's 10,000, maybe 100,000, because it's quite a niche market, and most of the people don't personally own a luxury watch, or just probably knew very few people who do that. So, but it's actually millions of users. We have about 9 million monthly active users. It's still growing, so we are getting closer and closer to 10 these days. And we have a high mobile community, so to say. We have about 8 million app installations. And the whole system is managed by a product and technology team of about 130 people. And this includes developers, of course, Java, but also, of course, front-end app development, and also UX, product management, Scrum Masters, and all the people that you need to build a product. And these are distributed among 12 Scrum teams. And an interesting fact about Chrono24 is that some time ago, we were on the list of the top 100 marketplaces by Anderson Horowitz. We were on place 27, which in and of itself is kind of okay. But the interesting thing is we were the first non-US company on the list. So that's Chrono 24. You now know roughly about the scale of what we're doing. We are marketplace. So let's now talk about why we are running our system on bare metal. And this is a question. So why are we actually doing this? Is a question that we get on a regular basis. And the last time we got this is during a technical due diligence where the consultancy came and they looked at many things, but they also, of course, looked at our tech stack and the structure and how we're working. And they asked, so why are you not in the cloud? Why are you doing this? So we had to answer that question, and we actually have a pretty good answer, and it's pretty much the same thing as I'm giving to you today. The thing is that there are, like, if you move everything to the cloud, it has a price. So one thing is that cloud computing is expensive. So companies start to realize that these days, and I saw a discussion at the WeAreDevelopers conference this summer where the founder of Basecamp, DHH, told about their move away from the cloud back to on-premise systems and bare metal and saving them $1 million per year. And this is a quote from a VP engineering of a fast-growing scale-up. So I had the pleasure during the past 2 years to talk to many engineering managers, CTOs, and ask them lots of questions. And this was one of the quotes that I got, that they basically saved $350K per month by just shutting down unused VMs and services. So there is a large cost and high expenses associated with cloud computing. So this is the first reason. Second thing is, if you move into the cloud, it usually goes along with a microservice system, and operating microservice systems is hard. So this quote basically says, okay, we have certain services, we have dozens, hundreds of them, but there are some where we don't really know what they do and if they actually still need it. So you have complexity there as well. And it's basically the thing that probably in the 2000s you had this computer under the desk of the most senior developers, and they had to be running all the time. You didn't really know what they're doing, but you also couldn't shut them off, so because then you were down. So, and this is kind of the same thing just in the cloud, and it's, in my opinion, even worse if you have something like this. And last but not least, if you have a problem in a microservice system in the cloud, you have a distributed system, and I don't know if you heard this already. There's this saying, like, the first rule of distributed systems is don't build a distributed system. Because if you have a problem, it's incredible. It's significantly harder to pinpoint the root cause, to pinpoint the problem, and to fix the thing. And this is just another quote saying that, okay, there was one of their core services down, like some core features were not working, and it took them 3 days before they really identified the root cause of all their troubles. And this is an issue. So if it takes you 3 days to fix a major problem, you're in trouble. So going to the cloud, using microservices and so on, have their benefits. So I'm not saying you must not do it. We are also using cloud features. So we're not black and white, but they not automatically solve all your problems. There is a price to pay. And you always have to be sort of judging and looking what's actually what I need and does it really solve a problem for me. So what we did, excuse me, I've got a bit of a sore throat today, so sorry. So we came up, or we actually had from the beginning a set of guiding principles that really helped us to steer our development and make decisions. And these guiding principles have been mostly coined by our founders, and they were actually quite experienced. So for them, it wasn't the first company. They already had sold one, and CTO at that time also worked in these companies, and he had built them up from the ground up as well. So he knew what things can go wrong and how complexity behaves. So he coined some guiding principles that really drove our development over the time. And these principles, in and of themselves, they are not new. So you've heard them. And they're not surprising. But they were actually really, really helpful in driving our decisions and coming to the solutions that we came to. And this is one of the important things to understand. Let's start with the first one. You definitely know this one. It's KISS, keep it simple, stupid. And while everyone knows it, not everyone practices it. And one of the things, or one of the reasons for that is that this term simple is sometimes understood very, very differently. So is it simple for me to build it, or is it simple for anyone else to understand, maintain, and continue developing it? And what we mean, and what's actually meant by the statement, is simple in the sense of the opposite of complex. So it's not primitive, and it's also not obvious. And the obvious and easy thing to do, for example, could be like, to give you an example that's not from coding, my wife, she's Slovak. So if she speaks Slovak to me, it's very simple for her, but it's incredibly hard for me to understand or even to answer in Slovak. So that's very, very difficult for me. So we don't want the easy and obvious solution, also not the primitive one, but it should be the opposite of complex. And usually it's a journey. You start with something primitive, and then you add detail, you come to something very complex, or might come to something very complex, until you really understand the essence of what you're doing, and then you can reduce the complexity and you come up with a simple solution that really fits the definition of opposite of complex. So that's keep it simple, stupid. Next one is boring technology. Boring technology, in our opinion, is good technology because we want to sleep well at night. So thing is, the newer something is, the higher is the probability that things go wrong. And if you have a large number of users like we have and a lot of traffic, everything that can go wrong will go wrong. So that's basically Murphy's Law. And usually it goes wrong when you don't really need it, and it goes wrong quicker than you think. So we want to minimize this effect. We want to have things that are proven, that are predictable, and also have no surprises for us. So we want to have our system to be boring. Actually, we recently had a short discussion about, should it really be named boring technology? Wouldn't it be better to call it proven technology, because it's shown that it works and all the problems have been solved? But I'm still more in favor of boring, because this is the effect it probably has on you. And it's also, during the development, it sometimes feels a bit boring because you're not using the newest fancy stuff. You're just working with things that are already there for 5 years, or longer, or 20 years, like Java, 25 years. So, and there's also this boring technology club where the term already has been coined. And last but not least, we have the principle of understand what you're doing. And this has two sides. One side is that if you have something that you can't easily debug and analyze, don't use it. And it doesn't mean that it can be complicated. Things can be complicated and difficult, of course, but sometimes it's really almost impossible to understand what things are doing. And this is the reason why we don't use Hibernate. Hibernate is a great tool, but in our opinion, if you've got a problem, if you run into a bug or a behavior you don't expect, it's incredibly hard to debug and to analyze and to understand what's really happening in the system. So we don't use it. The other side of this is, if you are somewhere in the code and you're trying to build something and change something, look around you, look at the classes, look at the structure, what was the intention of the author? Where did he or she want to go? So try to understand where you are before you work or make changes. So now let's have a look at the architecture of how things work. So this will be on a high level, of course, and just give you an impression what we do to achieve that. And if there's a time, of course, we can afterwards discuss a bit about what the details are, or probably how this can be transferred to your work if you're interested. So we have a scalable and manageable system, and the basic setup is, or the claim was, we can run on a single server, and we have about 43,000 requests per minute. So these 9 million monthly active users generating 30 million sessions per month translates into, on average, 43,000 requests per minute. And these can be actually handled by a single application server if these are just reading requests. We have quite a big system. So it's 2 processors, 2 EPIC processors with 64 cores and 128 threads, and it has 256 gigabytes of RAM. So it's quite a big machine, but it can handle all the traffic. And of course, we're not running our whole system on a single application server. That would be rather risky, right? So we have a replicated system with 3 more instances of the system. And of course, if you have such a setup, you also need a load balancer before it. And the next thing that we have here is our database. We use an MySQL Percona cluster, which is highly scalable and helps us to handle all the update and CRUD requests that we have on our data. And of course, people are searching for watches, so we need something to support that. We have a search cluster of Solr, based on Solr, and these are actually running together on the same hardware as the application servers are running. So that's the setup on our side. And then before that, so between the user and our system, there is Cloudflare, which serves as our content delivery network, name service, and load balancing. We also benefit from its security features. So if there is a DDoS attack or credential stuffing, things that are happening, Cloudflare really helps us to stop these things and get them under control. So how do we do that? How do we now manage to process all this traffic by a single application server? For that, we have, from the very beginning, built an ultra-fast caching layer within our system. So all the data that is needed for all the most frequented data that is used for reading requests is stored in memory completely. So all the listings of watches are readily available. And we do that in DAO, which is a data access object structure, which has sort of DAO-like interface. So you've got your CRUD operations there, create, read, delete, and update. And of course, we don't want to, we have this situation that we want probably just access specific entities of, say, specific listings of a particular seller, and not everything, but we also don't want to build a complete or use a complete in-memory database. So what we do is we have the concept of slices, which is kind of you could imagine it as an in-memory index of a database, but it's just a simple lookup, basically saying for this seller, or this seller has the following listings. So it's a quick association, and it's for on the implementation side. If you build the system, you really have to think a bit more, because you need to think about, okay, what data, what listings do I need, and then you have to build these slices, which are actually pretty straightforward to build, but still you have to do that. But then you have the direct access of the data. So that's pretty fast, and most of the requests are read requests that we get. So these 43,000 requests per minute boil down to 720 requests per second, which are just processed without even touching the database. And then if you have an update, we have about 30 updates per second. These are, of course, propagated to the database. So the database is updated. But as you've seen, we don't just have a single application server. So when the update comes, the DAO is updated, the slices are updated, and the database value is updated, but also the other application servers are notified. So they are informed that the change has been happening, and this actually happens within 3 milliseconds. So that's pretty fast. And also the whole response time, server-side response time of the request is pretty fast with 63 milliseconds. Of course, you can still have the problem that you send an update and a following request would end up at a different server, getting a different response, or see an inconsistent state. That's to be avoided. So our sessions are always sticky and pinned to one application server to avoid such problems. And last but not least, we have other applications that work with our data. So they need to be informed as well. And also, they don't have such high performance requirements. So they're not live systems for end users with millions of people accessing it. It's just in-house applications. So they need to be fast as well, of course, but they don't have to be as fast as our marketplace system. So, and they don't have such a high load and such a high demand. So we have basically a version of our DAOs that minimizes the memory footprint, and we call it remote DAO, which is basically just a version with LRU cache, which then also gets the data from and notifies the actual DAOs in our system, and also retrieves notifications if things are updated there. So that's the basic setup of our caching layer and how the notifications are sent around and things are updated. This really helps us to process all the requests that are coming from that we need to handle. But as I already said, it's not the only application that we run, because it's a marketplace and there needs to be work done. Like there's a bit of maintenance going on, so you have to look at different transactions. You have to answer questions of users. You have to do an onboarding for a dealer and so on. So this is all happening or done by our account management, customer relations, and many other colleagues working for Chrono24. And they have our internal application that we call Happe, which is also running on 2 machines and with a load balancer before it, and uses the concept of the remote DAOs to communicate with our marketplace. And last but not least, we also have a set of batch processes that need to be running, and they are basically separated, also individual machines, and can access the data as well via remote DAOs or local DAOs, whatever is necessary. And as I said, we're not black and white. It's actually a hybrid approach. Of course, we use cloud features wherever it helps us. And there's actually a very, very nice quote from Eliyahu Goldratt, and he said any technology is only as good as the problem it solves for you. So if you run into a problem where what's offered by the cloud is actually the best thing, why not use it? So we have mainly 4 things that we are using. We are using S3. That's where we started, because we have about 24 terabytes of images. So you could imagine every listing has about 10 images. They are uploaded, and we have about 500,000 listings. We also need to keep images of already sold watches, just for case of for legal reasons. So we have about 24 terabytes of images, which is also keeps on growing. And to manage that on a local system with your own storage is quite a pain. So we did that until about 4 or 5 years ago. And then we decided, okay, this is not it. We're going to move that to S3. And we did, and we're pretty happy with that. It's a very good thing, helped us a lot, made things a lot simpler for us. Next thing is we use Lambdas for post-processing and scaling of images. You could imagine that if you're browsing the web and are on our site, you see the image of a watch in very, very different sizes. So you've got an overview, you've got a very tiny thumbnail, then you're on the detail page, you have a bit of a bigger picture, and then you can zoom in and you can see all the details. And of course, in terms of response times and also traffic you generate, it makes total sense to deliver the image always in the best possible size for the user. And for that purpose, for that scaling that needs to be done, we use AWS Lambdas. We also have a quite strong machine learning team, and they are using LLMs and AWS machine learning services. So we have features like a watch scanner you can take with your phone. You can take a picture of a watch, and it somewhat guesses the manufacturer model and the actual product that you have. We've got a feed where, based on your previous behavior and interests, you get recommendations for watches. And we also help our sellers to improve the quality of their images based on what we recognize on the images. LLMs, of course, are also a topic here, and this is also something we don't host ourselves. We use it for generating text, for search engine optimization. We have about more than 50,000 products. So Core24 has the best and most complete catalog of watches that exists. And we have the products, and the products need, of course, some kind of description, and this cannot be done by humans. And we have, for each product, we have very interesting data and interesting information, and we use that to generate texts. And last but not least, of course, we can help our colleagues in CR to process requests by aggregating information and providing the right information to them. So this is sort of the first half of the talk. So let's look, what's the price? What's how's the bare metal versus cloud thing going? What's better? So the advantages of working with such a system is really its simplicity and cost, especially if we look at the ease of operation. So we have these 3 servers. We have, like, an on-call duty team, of course, you have to have that if you want to be up 24/7. But the number of incidents and the problems we run into is relatively low. And they are also, like, if there's a problem, we're usually very quick in resolving them. The whole thing is, from its architecture, I could now present it to you in about 10 minutes. It's fairly simple and not really surprising. So I doubt that any of you said, "Oh, I've never seen that before." So it's very simple. It's easy to understand. It's relatively easy to onboard new colleagues, and it's also really cheap. So we did the math and we came to the conclusion that it's about 10x cheaper than if we would go to the cloud. And the thing is, or would have a cloud-only approach. The thing is that this doesn't include labor cost. I've been asked that before. But first of all, it's not very high. So it's usually below half an FTE, a full-time equivalent. But it's like if you go to the cloud, there is work to be done as well. So it's not completely labor-free. So you have to do things, and you have to have someone who knows that and what to do. So that are the advantages. And on the other side, we have, of course, a set of disadvantages. And this is mostly related to flexibility. So we have a single application. So that's a single deployment unit. If we have specific requirements that only affect a certain part of the application, it will affect everything. So if we do something like, just to take a simple example, allow the uploading of images over our servers, we have to allow larger payload. And now we have to think about, it's allowed for everything, or how can we restrict that? So that's a simple example. But you also have that on the coding front. So you could say, if you have specific legal requirements, say for the whole billing and payment processes, and you need to document everything, or need much tighter documentation, how do you make sure that only a certain part of the code is affected by these regulations? And another thing is that we don't have the same performance in all regions. So of course, our data center is located in Germany, and the response times in Europe are very, very good. They're still good in the US, but in Asia, could be better. So this is a challenge for a global marketplace, but it's not the only challenge for being international, actually. Just to make that sure, especially in Asia, there are also different requirements on how probably the UX of the site should be. So that's getting there probably a bit more complex as well. And last but not least, we have a deployment wonderbag. So if you deploy, so you always deploy the whole application, and things can go wrong and you don't really know what you're deploying. So this is always quite exciting if you do that. But it doesn't stop us. So we actually deploying multiple times per day. So that's pretty good. So we're actually happy there, but still it's this wonder bag, and it makes deployment a bit more exciting. Okay, but still complexity. Let's be honest, if we have such a system over time, it will inevitably become monolithic if we don't stop it from developing in that direction. And we, excuse me, we've actually been there, and this is something which in professional circles you call a big ball of mud. What you see here is the biggest class circle that we have in our system. So here every small rectangle is a single class, and every arrow is a dependency, and basically you can go from every rectangle to any other rectangle here and find a path back without visiting the same class twice. And I'm pretty sure there's more than one path for most of the cases. So this is quite an issue, because here it's impossible to split the system in separate parts. So even if you would say, okay, we want to have separate modules, it's not directly possible, because you have this high entanglement. And there's also been a lot of talk about cognitive load these days, so that complexity matters. So how much do you have to understand to really develop something or fix a problem? And the cognitive load can, of course, be in the deployment structure and the setup there, but it can also be in the code and in the dependencies there. So there's definitely something we need to do about this. And last but not least, since everything is in one application, there's no clear separation between what's actually our core business, what are the differentiating factors of our application, which is just supporting and helping us to do our job, and which are parts of the application are actually generic and could be replaced by components off the shelf. So the challenge now is that we actually have to do something about this. So we must change that. And but we have the challenge that product development, of course, must continue at the same pace because competition is not sleeping, things are changing. eBay is getting into the luxury category more and more and more. So we have to position ourselves. We have to do something now. But how the F are we supposed to achieve that? So how do we deal with this and still move on quickly? And this is something that I personally call it the technical debt dilemma. And it's something I've been facing in my career on different occasions again and again and again and again. And it's always the conflict between let's build something now or let's improve the system, let's tackle the tech debt. And the conflict is basically saying, so we want to be successful in the future. This basically means that we need to react quickly to user needs in the future. And in order to be able to react quickly to user needs in the future, we need to maximize the maintainability and flexibility of our system, which translates to we need to reduce technical debt at the moment. But to be successful now, we actually have to react quickly to user needs now and the market demands now. And we must maximize our customer value and work on the next features. And so what should we do? And probably you had such discussions as well. But my assumption is that this is only, it's a false dichotomy. So if we look at the assumptions behind it, it will become obvious. So the first one I would like to point out is that if we reduce technical debt now, the code base and the architecture are significantly better in the future. And I don't know if you've had this experience. I definitely had it, that you look at some code, you think, oh, I should refactor this. This is not good. You do a refactoring and you're pretty happy. Half a year later, you come back and look at it and think, what was I thinking? So the point here I want to make is, if you think you're improving something, it doesn't necessarily mean that it is actually better in the future. And there are a couple of reasons for that. Yeah, you need, first of all, a common understanding of what this better actually means in your teams or in your team. Because if you don't agree on what's actually better, then developer A moves in this direction and developer B moves in that direction. So that's a bit of a problem. And whenever developer B comes to code from developer A, he will move it in that direction and it goes back and forth and they will never agree. So you see the problem. Last, excuse me. Next, you need clear criteria how the new solution needs to be better, because you can have two solutions which are both valid, but just depending on whether performance is more important or maintainability is more important to you, each of one could be better. So you need to know what are the criteria you're looking at. And a good architecture is always determine what is built next. So if you try to optimize for everything, it won't work. You will be over-engineering. But if you really know what's coming, or at least have a bit of a look ahead, then you can build a better architecture or a better structure for your system. And that brings me to the next point, because often we perceive it as a conflict that you can either do the one or the other. But already Martin Fowler pointed out quite a while ago that it doesn't have to be the case, because like whenever you build a new feature into your code base, you can actually look at it, look at the code and decide, okay, can I build it in? If it's easy, do it. If it's not, probably I need to restructure my code so that it becomes easy to build this feature. And with this philosophy, we can actually reduce technical debt. We now know what this better is. We then know what, like if we have a feature or even a bit bigger product change or whatever you're going to do, you know where you're going So now you have all you need to really build a good structure that fulfills the needs that you have and really have a good opportunity to reduce technical debt. You actually also have the right part of the system where it's worth reducing technical debt. So one of the assumptions one always faces is that whenever somebody finds a piece of technical debt, it's necessary to be solved. But it's not really true, because not all technical debt is equal. So some is generating high interest rate and other is rarely touched and works fine. So it doesn't generate so much of a headache. So with this, we come basically to a set of rules and guidelines how to approach this technical debt dilemma. So first of all, we need this common understanding of the desired state for all engineers. So we need kind of blueprints, in-house design patterns, kind of a codex, how things should be done, some criteria. We need to apply the scout rule. Basically, whenever you find something, it's Pfadfinderregel in German, when you find something which sort of deviates from your ideal state, which is now defined as the blueprints and based on the criteria, you improve it a bit in that direction while you're working on your feature and your next step you're going. And last but not least, we follow the Strangler-Fick pattern. So you're not doing everything, but you pick out the parts you're working on anyway, and then you drag them out of your big ball of mud and you rebuild them as a separate part of your system. And the term Strangler-Fick comes from an Australian plant, which basically grows among the trees to reach the light faster, and it covers at some point it really covers the tree and strangles it until it dies. So that's the idea here. So more and more parts of the system will be rejuvenated, and at some point the old system is not needed anymore. So much in theory. So sounds are good. Now what? So we want to keep the benefits of what we have, the simple deployment, simple operation, and also the cost efficiency. But we also want to increase the understandability, reduce cognitive load, create a bit more flexibility. And our approach there is modular. So first thing that we need to do to get there is we need to structure it according to domain-driven design. So that's the approach we chose, because domain-driven design really helps us to identify the subdomains, the parts of the system that have a loose coupling and a high cohesion, and also help us to work on the organizational structure. So these subdomains can then be owned by a team, and this team is fully responsible for that part of the system. So we have to look into the domain architecture. We have to go and define good coding rules. We need good conventions and guidelines for the subdomains, how to set them up, how do they communicate, how do we want our system to look like afterwards? And on the whole setup, we need to follow the Strangler-Fick pattern. So we need, whenever we touch something, we can look at it and we can say, okay, this is a subdomain, let's migrate it to the new structure, do that. And also if it's a subdomain, we say, okay, we probably shouldn't do that ourselves, find a solution for generic which is off the shelf, which is already there on the market. So domain architecture, I don't want to bother you with all the details, but the idea here is the green post-its are subdomains, the orange ones are domain events, and the black boxes here are actually organizational boundaries. Just to give you an impression, this one already points out some problems, but they are actually organizational. So this is very interesting. So whenever you do something like this, be prepared for organizational challenges. So we have here, obviously, one part of the process with a couple of subdomains involved, which is highly coupled to a process on the right side, which actually is in a different part of the organization. So this is interesting. We also have one thing here, which is a potential subdomain. It's not all clear that the whole big green box, and that one nevertheless would be also distributed among 2 organizational units. So we already identified interesting things here, and it already helps us to understand our system better. But now we have to think about, like, we have the domains, what do we do with them? So how do we implement them? So we still want to keep it simple. We want to have a sort of approach where we evolve to the new system, where we actually can keep on delivering features, where actually the structure we set and the things that we introduce help us to build new systems and not really stop us from doing that. And so we came up with a set of rules and guidelines. I don't want to dig into all the details, but just to give you an impression, it's very simple. It's just a layered architecture with all the layers that you know. So you have a presentation layer, this is basically the controller layer, you have a service layer and a repository storage layer. But you've got the access rules from where you can access what. You've got the boundaries. These are, you could say, it's basically the interfaces, the APIs between the subdomains, and you have rules for what can be accessed from where. So this is on a very high level, and now the question is, if you have such rules and guidelines, so you've got the access rules, you've got probably some coding conventions, how things are named, how things should be structured, which code should go where. How do you come to such guidelines? How an API should be designed? Where does what data go? How is other entities structured? Whatever. How do you define them? How do you get to these solutions? And well, it's very easy to say, like, how not to define them. So one person defines all the rules and they're set forever and must be followed by everyone in all cases. So that's a very bad idea. So from there, we can probably derive what would be a good idea. So it should be a collaborative effort. So people should do that together. We need to discuss things. We need to come to a point where we really understand what does good code mean for us as a team. We need, which helps us then to formulate the criteria. And we also must be sure that they are not cast in stone. So they must be improved continuously with feedback from the teams, from everyone, so that we don't end up with something that really blocks us and feels like something that makes us unflexible and doesn't help us to really code and move forward. Next question that we're facing is then, okay, now assume that you have your rules and guidelines, how to make them stick. Because people forget the rules. There are new people coming who don't know the rules. If there's documentation and everything's described, that's good. It's a big progress already. But documentation is boring. You probably read it. And in the moment, it doesn't really affect you. So you tend to forget it again. So, and probably there are also situations where it's just easier to use this shortcut. So we need some means to make them stick. And we chose actually ArcUnit for it, and it helps us to really implement and specify the rules in Java and run them together with our unit tests. And the big advantage is it allows us to freeze existing violations and just fix them step by step. So you can take a part of the system, you say, okay, this is a new subdomain, you move your stuff, there are still violations, that's fine. Then you can reduce them, you can build your new code, and eventually you're able to extract a complete independent module. And the good, another important thing is that whenever a rule is violated, it makes sense to point to the documentation where everything is explained. So why do we have this rule? How should it be structured? And how do you get to a nice setup here? So last but not least, follow the Strangler feed pattern. So migrate code of a subdomain whenever you're working on it, find off the Shaaf components for generic domains. We talked about that, and that's actually how we approach this. So even though the picture is not complete and not everything is clear that yet, parts of it are already clear, and we're working on them, and we know pretty much what we're doing, and we can already build the individual modules and subdomains here. So that's the approach. That's how we're working, and this is how we keep complexity as low as we possibly can. And this brings me to my key takeaways for today. Keep it simple, stupid. It is possible to run a global marketplace with millions of users on as a single application. And it's, of course, it's not easy. So you need to work and fight back on complexity all the time because it's creeping in wherever. If you don't really fight back, it's just creeping in everywhere. And for that, you need clear principles, you need rules, but you also need the right culture and mindset of people that are really aware, okay, we need to fight back on complexity all the time. And we really need to think about, isn't there a simple solution that really solves the problem and is simple in the sense as the opposite of complex? And then you also, of course, you need a system, you need a setup where you can not only rely, we must not only rely on the discipline of each individual, but you have to have a system where it's easier to work within the framework that's been agreed on than to just circumvent it or do your own thing. And last but not least, structuring a system and finding a good structure is really an important thing. Taking care of it, it's a continuous process, must happen all the time, like fighting back on complexity. And it absolutely makes some sense to get some help here. So that brings me to the end. Thank you very much. And I'm really looking forward to your feedback and the discussion. Thank you.
Hello. I feel like I owe you like a bag of cough drops because you've been soldiering on, although your throat was like hard, your
Sorry for
hard
that.
time.
Yeah.
So yeah, it's thank you so much. This was great. This is I mean, especially the detail, and I love when you brought the diagram up and you're like, I'm not going to go into detail. I'm like, thank God, that was a huge diagram. That was interesting. One question we got was like, might be addressing issues in microservices environment is hard and at cost, but when going to microservice, we should be ready with tools to fast analysis for issues like distributed logging. Not really a question, so I don't know what we're going to do with that.
It's true. We can just discuss it a little bit. Probably you have opinion there as well. So
Okay.
of course, you need tools to help you in any case. You can have distributed logging, but you can have, in a distributed system, you can have concurrency issues and problems that you can't have in a single server application.
Mm-hmm.
That would be my point.
One thing I found interesting when you talked about cost a lot, and you talked about 24 terabyte of images on S3.
Yeah.
Is there a way to actually pay differently according to how many times they are being accessed, or if they can be like frozen and just basically say like, these are just, we need to keep them for legal reason, but the listing is not live anymore. So do you pay differently for those?
Yeah. You can move them to different storage. So there's different storage and access levels. So there are different payment level fees as well.
And I guess Cloudflare also helps with caching, so they're actually not getting access all the time that way.
Yeah, lots of.
So what I liked a lot is like the thinking, the deeper thinking in the company. Like here's the documentation, here's how to do it. The thing when you said like that, if you either have tech debt or you have new features, it was always the thing like you get the junior developers to look at the tech debt things and fix them and actually find out about the structure of the product that way. But it's a very non-thankful job. So how do you deal with fluctuation in the company? How do you deal with like brain drain and people leaving, or is this not an issue for you? I mean, I worked at Microsoft before, and we're like, by the time I trained somebody up, he left the company. And that was the really frustrating bit about this. Do you feel similar things?
Not at all. We have most of the people are really staying very, very long with the company. So we are still a young company, and we've been growing for quite some time, and all the people I trained are now there like 5 years and more. So they people just stay because we have a very strong culture, and yeah, it's not a problem, not an issue at the moment.
Mm-hmm. So you're not distributing your systems, but are you distributing your people? Is it a remote company, or are you in the same office?
It's hybrid approach, and we have people working fully remote. Of course, it increased and is growing and increased. This started with Corona, and also the office policy is usually to say, okay, 2 days in the office, 3 days from home. But it's very flexible.
Mm-hmm. Sounds good to me. So in terms of like sizes, how many people are you on the project continuously? And is there any rotation on like different tasks?
Okay, we can talk a bit about the organizational structure. So we are separated into so-called product areas, and the product area contains about 30 to 40 people. And these 30 to 40 people work on a particular part of the marketplace. So say the user side or the seller side, just to keep it simple. And within that setup, or within that range, there are there's the opportunity to always work with different teams. So some of the product areas use approaches like dynamic reteaming, and depending on the initiatives and things that we want to achieve.
Mm-hmm.
Does it make sense?
Yeah, that does make sense. Yeah. The interesting bit about that as well is like when you talked about the tech debt thing, did you have any findings that you could release to the world in some way or another? Do you considering having a blog or write about them or guest blog somewhere else, or do you also contribute back to open source with some of the things that you do, or is it something that you're not having time for yet?
We contributing back to open source. So on GitHub, there's a Cron24 set of repository accounts, so where you can look at everything that we've published. We have also, like, some of the developers are, of course, they are loving their craft, so they are also privately contributing to open source, and we support that heavily. So we have every sprint, we give developers a day for their own projects and the things they would like to do. And personally, I have a Substack blog where I write about the things that we do and what we're doing in the company. So if you're interested in that, yeah, feel free to subscribe. I would be happy.
Excellent. That's good to hear. One of the things you talked about is as well as code standards and code environments. What I found interesting when I started playing with GitHub Copilot, and I guess AWS has Code Whisperer as well, is that it started mimicking the code of different developers, and that we found a consensus through a Copilot kind of thing, or through a generative environment. Have you looked into something like that, and do you think this is an interesting way? Because the consensus of finding a code standard is always like month and month of communication that is actually most of the time for the bin.
Yeah, I understand it. We have Copilot, and I forget what the JetBrains version was called. So
Replit?
Sorry?
Replit? No, there's several ones here.
I think it's the JetBrains AI assistant. I think it's not a very creative name. Anyways.
Must be German.
Yeah. Anyways, yeah, people use it, but I didn't see that it helps in developing coding standards, or that there's some patterns evolving over time. So that's something I didn't at least recognize. So it might be happening, but I didn't check for it. So
could be a front-end thing that it actually learns more from front-end code rather than others. But I found that an interesting approach, because it's tricky to do that. So if there's one thing that you could do differently, that you spend far too much time on and found out that it's wrong, what would be one thing you would tell people to avoid?
If we're only talking about technology and structuring systems, It's hard to say because hindsight is always wonderful, right? I would say we should have started the whole restructuring and the split up to a monolith probably 3 years earlier. So that was a good time. I wouldn't say start with something like this because in the beginning you don't really know what you're building and where you end up. So you also have just a low resolution of your domain and of your business. But once you have a high enough resolution and complexity grows, it's time to slice things apart and structure things. Well,
excellent. We're almost out of time. One question came from the audience, like, what do you do in terms of onboarding? How do you get junior engineers to start embracing and understanding the architecture? What's your approach to get them hit the ground running quickly?
It's mainly training on the job. So we have mentors for people coming to the company, and they are basically taking them through the whole system. So we have like you start with a few like simple default tasks, and then you start with shadowing a senior developer, like who explains things, and then you stepwise move to pair programming, and from there you get your own first stories and move on. So that's basically the approach. It's basically just having a mentor guiding the people over the first 6 months to probably a year, depending, and then
cool,
they're ready to fly themselves. So that's our approach.
Are you hiring?
Sorry?
Are you hiring?
At the moment, we're just looking for a senior iOS developer, so not Java at the moment.
Okay, senior iOS developer, fair enough. Well, good luck. I know a job board where you can ask for them and look for them.
Yeah, I've heard about it too.
Yeah. And well, that was Jens Happe from Chrono24. Thank you so much for your talk, and the video will be out soon as we cut it. And if you need any really expensive watches, you know where you get them now, and also where to learn about Java architecture that actually works. Thanks very much, Jens.
Thanks a lot, Chris.
All right, which means we move on to the next person, and I'm very excited to have like somebody from a big company here right now. Syed Shaaf, I hope I pronounced that the right way. It's good to talk from one Red Hat to another. And I think we're going to be diving directly into it, but let's quickly get him on stage and say hello. How are you doing?
Hey, good. How are you? Good to be here. Yeah, fantastic. And in a rainy weather, couldn't be better. So
Where are you based?
I'm based in Copenhagen, Denmark. So
Oh,
not very
splendid. Yeah, love it. Lovely place. Also very easy to go to Sweden from there, just over the bridge and you're there. It's a wonderful
Yeah,
place.
exactly. You've been here. Yeah.
And don't buy any alcohol or any food without everybody else paying it on their company bill. So that's a better idea. So what are you going to cover and what are you going to talk about today?
Yeah, so I've been working with the upstream community Conware, and we've been doing work around how you can modernize applications. We've done something before in the past for a couple of years where you could do some static code analysis, but with the advent of large language models, it becomes extremely interesting. So what I'm going to share today is what is the whole chain of process and thought, and what are we doing? It's not just another chatbot, because that's what the world is full of these days. So what do you do when it's not a chatbot? What does a use case look like? So we will go through that, and then of course I'll do some demo as well between the presentation off and on. So yeah, we'll try to keep it interesting, and hopefully you will all enjoy and learn from what we've been learning.
I love it because I think there is a big space for Gen AI in like converting old code or legacy code and fixing it, rather than like generating a new app by a click of a button or a prompt. So this is some real life problems to be solved with newest technology here. So without further ado, I'm handing the stage over to you, and I'm going to be listening and taking notes here when the dog doesn't annoy me, and we go from there.
Perfect. Yeah. I locked out my cat as well. So no, I didn't lock out. Sorry. Okay, let's move on. So yes, glad to be here. My name is Syed Shaaf, principal architect at Red Hat. I've been at Red Hat a long time. I'm going to talk about application modernization and how you can leverage Gen AI. I've been a Java developer for quite some time. Well, I'm not going to give you the years, but I'll say like this, that I have worked on AWT, I've worked on Swing, I've worked on version 1.1 as an example. So yeah, so it's been a long journey. So I love Java. I've been working with it in multiple roles all over the years. I write for InfoQ as a Java technical editor, so feel free to follow me there, and you can hear a lot about Java and monoliths and modulates and everything that I can write over there. I'm happy to share. And then finally, of course, or maybe the most interesting thing, I also am a coach or cricketing coach as well. So I do some sports there just to put some personal touch here. And then obviously Conveyor contributor, where I work with the Conveyor community, which is what I'm going to talk about today. And if you want to follow any of my feeds here, feel free to, and I'd be happy to respond. So let's get on and talk about what application modernization is. It's a fully loaded word. It can be very specific in some terms, and it can be extremely broad. So what does technical debt mean? Is it really bad? Is it really good? I mean, I'm not going to get into that, but I guess I'm going to get into more why it's so bad, right? If you look at the McKinsey report, for example, they talk about approximately 40% cost in terms of IT balance sheets, but then also 10 to 20% cost in actually getting rid of that technical debt. And Jens from my previous, the previous speaker on the talk had a very good point here, that why do you need to, and I think I probably read between the lines, why do you need to wait for it to kind of fix the problem? Why don't you fix it now? And fix it in your practice now, and make sure that you're continuously improving that. And I think that's a very good thought, and that's exactly how we should approach these problems. But the reality in this world is that not all of us have this sort of opportunity to do so. And there's code that is written even in Java for, like I said, I've been there for a long time, that is still there. Like I see struts applications still out there on older versions, and they have many, many issues. And we'll speak a little bit about what those issues are, right? But so technical debt does increase the cost. Another research by Sonatype, for example, is about 200 projects within a span of 12 months, $306,000 per year for a project for just million lines of code. And million lines of code, last application that I was modernizing was about 80 million lines of code, right? So it's an extreme huge cost. It affects business processes, it affects a lot of other things. So once you hit that kind of tangent where you have technical debt in large projects or large companies, for example, you will definitely hit a problem. But if you have a smaller base to cover, you might have some tools that you can start off with and do it continuously at the same time, as well as be able to take a little bit of hit around how you can do it. The issue obviously arises is that 1 is easier, 100 is harder, and thousands is even harder. And I have had to deal with modernizations where customers had more than 2,500 applications, and then that's a serious lift. When you hear about old Java web servers and etc., or Cold Fusion, it scares you sometimes. So how do we get out of that? Get out of that pit of legacy applications? That's what my talk is going to focus on. What I'm not going to focus on is domain-driven design and some of those other paradigms, and I'll speak a little bit detailed so you kind of get the hang of it. Another important, kind of matrix is around 742% increase in terms of the software supply chain attacks. 45% of organizations experience it more than ever before. There's edge computing, there's deployment on the cloud, there's deployment on premise. There's all kinds of these different softwares that we are running, and we get hit by these security risks as well. So it's extremely important getting into not just the supply chain, but also understanding how do we actually come out of this. What's the approach? Because I have an application that was maybe written in Cold Fusion or Struts or Java EE, or Java J2E, for example, many years ago. The developers have left the building, and the code is hard to understand and kind of refactor. So what do I do? What choices do I have? And when you look at the choices, sometimes the choices can be scary, because now you're talking about distributed architecture, event-driven architecture, and all these different cool kinds of things. and here you have just one server that's running everything. So what do I actually do to solve this problem? So it can be overwhelming. I totally understand and agree with that, but there has to be an approach where your business does not completely shatter off because you are depending on old and legacy code that can have serious issues. That also means lack of agility. For example, you are no longer allowed or able to keep up with requests, keep up with new frameworks. Maybe you were not able to have a React front end anymore because your application has a lot of state that just lingers around in the back end. So you have certain challenges. Maintenance cost is also another one. So you basically end up maintaining these big software contracts or just the operation. So it takes a lot of nurturing, not a lot of time to take care of these applications. Is it bad that there's technical debt? To some extent, yes. If you are vulnerable to security risks, if you are not able to meet your business demands and grow and diversify, and kind of even not able to get out of where you are in terms of cost and efficiency, or maybe for some not even able to go to the cloud because that's the thing that the company is focusing on, you are seriously having trouble. The other thing is obviously your design, and you might want to have a domain-driven design. You might want to be in an event-driven architecture, as an example, or you might want to feed into real-time live events, as most of us do in applications today that are living on the web, as an example, or on your telephones and devices and edge devices, etc. And you're not able to kind of modernize or have new patterns that you can have in your application that can help you to deal with this problem. So it becomes difficult, and that's the whole premise of why and what we're going to talk about today, as to how you can solve this problem. Obviously, not every problem solved is 100%. There's always human intervention. There's always a mindset and culture and other things. But today, what I'm going to talk about is what tooling do we have to address this. So has anybody of you seen this code before? Do you know that maybe this still uses EJBs? And have you recently seen an EJB remote object? And just be honest with yourself. If you haven't, it's awesome. It's great. I see them quite often sometimes. So what do you do with an old protocol, with an old layer that's inside, and then there's a lot of value objects and business objects and data access objects, etc., and all of them sort of standing over within one one specific monolith style application? How do you actually get to move? And not just that, hey, I want to create microservices. It can also be a monolith with a new framework as well. It doesn't matter. It all depends on how you craft your architecture and what you need at the end of the day. So we see this, I see this, and I'm sure you see this as well. Does anybody know what this code might be, for example? I'm going to stay silent. I can't see your comments, but I'm just going to give you a second to reply if you can. So what this code is basically doing is, if you look at it, it's a simple Java code. It's a CVE from, I believe this is from Text for Shell. Yes, this is from Text for Shell. And Text for Shell was basically was using the Apache Commons library, and it could actually interject a JavaScript into your runtime. So have fun with that, right? And if you had that in your code, and maybe you just put it everywhere as part of a pattern of doing it, when you did that, you might not realize it, but now there's a new vulnerability that comes out, or it's not too new. It's been about 2 years now, or 18 months roughly. And you still will find this in code places at certain areas. So how do you find that out, and what do you do, and how do you remediate this? You can do it in one machine, then you can go start fetching in others. But what if there was something that could do something similar for you to help? Here's another example. This is the this is the log4shell example, right? So here you have a logging error, and there's a user input, and the user input could just be calling, for example, your JNDI LDAP server, an extremely secure server, and then you can attach malicious code to it, right? So you have and look at these examples. Like, these are super simple. When you're coding, you're not thinking about, yep, I'm going to log an error. User sent me an input. I'm just going to throw it out. perfect. But when you do it, and certain couple of years later, you find out that, oh, now that was not secure for me, right? So there are certain challenges even to carry this sort of practices, and once you have them, they're all over the system. So how do you manage to ensure that you can actually come over them, and what's the solution there? So one of the things that we have done in, for example, in Conveyor.io, which is an upstream open source project, is that we built the analysis rules engine, and it's similar to many other rules engine out there. It also uses the language server protocol. So what it does is that we have more than 2,400 rules that you can use, and these are all community-driven contributed rules, which you can do static code analysis on. And once you do that, the engine takes over. The engine goes through the entire source code that you have, the source repository that you have in there, and then it starts to analyze it and starts to give you the code paths as to where these problems, for example, arise. Problems or incidents, as I think incidents is probably a better word to say, and incidents that you feel are incidents in your code repo. So for example, you could take a practice in your design and say this practice is no longer used anymore. Like, we're not going to use log4j anymore. We want to move to SLF4j or something simple or different. You'll be able to do that. Or if you see these specific exceptions and errors, I want you to start adding distributed tracing calls to it as well. And so you can handcraft some of these rules and say that this is how I want my code to be checked and analyzed, as an example, with the 2,400 that are already out there. And you can target exactly what kind of incidents you wanna look into it. And I'll show you in a second, or a minute or so, right, that we can go over that as well. So it basically informs us, gives us some view of what's going on in that, and then obviously we want to take action on it as well. Here's an example, of a JMS topic that is being used, and you might want to change that JMS topic to something else, but obviously it's giving you a full report of, hey, what this code is, what the target technologies could be that you might choose. In my case, I chose Quarkus here, so it gives you some recommendations around what those might be, as an example. So let's just quickly take a look at how that would be. I hope you can see my screen. If not, just push it and push me a message here, and I'm going to be able to kind of pull this up. I think I already zoomed it, so we see it here. So here, what I have is something called a conveyor.
Can you zoom a tad more? It's actually hard to read.
That's exactly why I gave you my cue. Yes. Thank you. Thanks. Perfect. So here, what's happening is that I have a configuration. I've created a configuration for doing the analysis. So what I do is I say, hey, my configuration is called WeAreDevelopers because it's an awesome day today. It's a Java day. I select a Cantra CLI, which is our tool to do the LSP analysis together with. I have a cool store app, and I'll speak a little bit about it in a bit as well when we go into the next part of the demo. And let's just say that it's just a simple Java source code repository. It's a test because this is one of the test repositories. It's not actually test, but it's actual code. And then I say, hey, I want to be able to analyze my repository so I can check what could be my target. And here you'll see a lot of targets. You might want to be going into Azure. You might want to be doing Camel. There are different versions of Camel. You might want to check your cloud readiness, so containerization, etc. Rule engine, different technologies, JBoss as an example, Hibernate, etc., etc., etc. So what I've done is that I've searched Jakarta EE here, that I want my Java EE application to be analyzed basically on what Jakarta EE should be. So how do I move or migrate? And then I've also selected Quarkus, and here basically I just want to make sure that I can use Quarkus to do that. And if you know about Quarkus, Quarkus is also one of the Kubernetes or cloud native frameworks that can help you write, microservices, applications, serverless, functions, etc. It's much more faster. It has a less footprint, etc. And it's in the same area where you can see Micronaut, where you can see Spring Boot, etc. All of that kind of lie in that same sort of paradigm, right? So it doesn't stop us from creating a monolith from a monolith, to be honest. And that's what we're going to do here, even though that we have, the world is full of microservices. But in this example, to keep it simple, I'm just doing the analysis, and I want to see what that might look like. So if I look at my inventory entity, so if I run the analysis, it's going to take me about 2 to 3 minutes. I'm just going to save that time for now. When I run this analysis, it's going to give me, let's say, a report. So let's take a look at an HTML report. So basically, when you run the analysis, you can also run it on a Kubernetes environment. So it runs online, and you can connect online and do that. So it also gives you this HTML output. So let's quickly take a look at the HTML output. Makes it easier and simpler, right, for visibility as well. So I see I've done some analysis. Once I've done that, there's 117 incidents, and these incidents have been reported. So if I go into here, I can see, hey, there's move to Jakarta E Maven artifact, which is POM XML, and this POM XML has a certain documentation attached to it, how you could do that, for example. Then there's also implicit name determination, like how you, for example, use Hibernate, etc. So all of that you have over here, that kind of gives you the details, right? So it also has an HTML. I just wanted to show you HTML. I'm a developer, so I'm going to get back to my developing here. So here's my Visual Studio Code. And in Visual Studio Code, in my extension, I can see, hey, replace Java persistence. So let's take a look. It says, for example, you have this class, which is JavaX persistence, that needs to be moved. There's other elements. So let's take a look at it. Let's take a look at the details. And it goes into the details and explains some that you need to replace JavaX persistence to the import statement to Jakarta. Now, the interesting thing is, because the LSP is working, it's going line by line and taking each and every incident out, which means that you can manually change this incident by yourself right now, and make it to Jakarta IE and try to compile it and see if everything works, right? So this is more like, at this phase of the project, all we have done is reporting. We're only looking at all the incidents that are out there, and what kind of incidents these are, right? And how do they affect us? And then we can go in and say ambient clean compile, and then we can compile the entire application, and that's pretty much it, right? So that's what it's doing in simple states. It's just giving you what the different incidents are. And here, most of these incidents are related to JavaX, to Jakarta, as an example. So I just wanted to show this because this creates the premise of how we integrate with large language models. And mostly, you will see that the code or most of this is done today. If you see most of the demos and tools out there, they're talking about how you could do this in a chatbot. You have this conversational state, which is very valuable as well. Let's not take that away from it. But then what if you were able to apply this not just to one repo, but to many repos, and the patterns that you identify in your organization, apart from the ones that you already get from Conveyor, that you can enforce those also into your code bases across, so that reduces your technical debt as well. So let's go ahead. Nice picture. I did the demo already, okay? So sorry about that. We're going to do this second time. We'll have the same picture. So introducing Conveyor AI. So what is Conveyor AI? How do we mesh this, not the chatbot sort of experience, but this static code analysis experience, this use case, into how we actually do the generation of code? And that's what we did with Conveyor AI. Earlier this year, we started to look into a very simple concept as to how do you mesh that static code analysis and get exactly what you want from any LLM, not specific LLM, not locked into an LLM, but you can use any LLM that you wish. And what we have seen is that different large language models have different responses based on what language you are using. So a model might be very good at .NET, and a model might be very good at Java, for example, or vice versa, different languages, right? So there are elements where you will find these different models, and you should be free to choose how you use these models and have a choice to choose any large language model, right? So we don't restrict that, and that was one of the first principles we have in the Conveyor IO project. What we also do is, obviously, just to give you a bit familiar, is that Conveyor is a CNCF, Cloud Native Foundation, and it's a sandbox project within there. The whole idea of this is to have a predictive, code that is generated, not a predictive code completion. So the tools that you see that does predictive code completion today, this is not what it does. It will give you an output of what needs to be done. And I'll show you that in a bit as well. It doesn't do fine tuning. We're not fine tuning models. So this means that your choice of using your models is still with you. We use RAG and we use few shot approach, for example, to do this. So you're able to look at that as well. And I'll showcase that to you. What does this mean? What is this mesh that I'm talking about between static code analysis and large language model? So what Conveyor does is that all the generated source code analysis, like the ones we just saw, it will pinpoint what you need to do to adopt this new technology. Like in our case, from a Java EE application, it pinpoints how you can move to Jakarta EE plus Quarkus style application, right? It also has the history change log, which basically says before and after. So you can see that. So you can use Git. It has a Git patch, so you can actually put this into your Git repository as well. What obviously I would recommend is that when we do such an approach, we branch this out in our Git and we start to work with it step by step, changing each and every aspect of it, right? So that's how you would use. It use crafted prompts. So we have prompts that specifically work in this way, and then obviously it has an IDE extension in VS Code and stuff that we're working with IntelliJ and Eclipse and some of these other IDEs as well that you will see in coming months as well. So how does this work? I've said this a lot. In terms of the application, you have the developer that works with the IDE, like I showed you earlier. Then you have the issue, and you can look at what the issues are. You can ask the AI, the large language model, to go and based on that static code analysis, because what we do is we're going to give a lot of hints into that system. And then obviously you can what Conveyor AI, which is a backend module, which will take all your inputs and create those recipes and hints into the large language model, and then ask large language model to do this for you, and then give you a generated patch that you can use as well. So that's how it's sort of working. If I give it a bit more detail, you would see like, okay, I have done my analysis. Here's my suggested code fix. I accept that code fix. LLM gathers that data, and one of the interesting thing is that we have an incident store, so that keeps on learning and keeping your information as well at the same time as well. So when you apply from one application to hundreds and thousands of applications, it can learn over the process and actually smartly give you recommendations of incidents as you move forward as well. There are other things that you might want to consider, like in large language models. You have context windows, right? So you think, okay, I want to go to the fine-tuning approach, but fine-tuning is not that, it's not cheap, right? It has its costs, it has a lot of work that goes into it. There are already models that kind of do this. So why not use the RAG approach, make sure that we can actually use the RAG without fine-tuning, and within that context window be able to do it. But obviously context window has its limitations as well. You can't throw an entire repository into an LLM. You need to be smart. You need to understand what you have, and that's exactly where this comes, is when you have the static code analysis, it is able to mesh that together with the large language model and give that hints as you go further as well. And obviously it integrates with multiple models, like I said before as well. So this is what we will do. I'll show you the demo in a bit. There's going to be a source code repository like the cool store. We've done the static code analysis. We're then going to request to the large language model to give us the responses, and it's going to aggregate the responses and bring that back, because we are doing few shot and we have context that is going to play inside there as well. So let's move on to the demo. I'm going to go back to the slides in a bit as well, but let's move on to the demo. What I will do now is I'm going to start my, I'm going to zoom this. I think that was, yeah. So first thing I want to do is I want to start my backend database, which is for my connecting. When the large language model connects, there's some inference I need to store. So I'm just going to make that, and I'm going to store that into the Postgres. So at this moment, what I'm using is Kai, as we call it, Conveyor AI. I'm going to basically start the Conveyor AI backend. And today, because we are still in development and coming out with releases quite fast, we are still actively doing that from either a Docker Compose file or from the source code as well. The second thing I want to do is that I want to start my server. And once I want to start my server, I want to make sure that it connects to, for example, the large language model and is ready to accept. So here you will see that my application is ready to take requests, and it's ready to listen, and it's using, for example, right now Mistral on top of the IBM Cloud at this point, connecting to it and using the Mistral 8x7b instruct model to generate my source code as well, right? So, and all of the hints, etc., that I do through this process are then stored into my database, right? So let's go back here. Let's go back to our analysis. So here, if I look at the inventory entity, it had these different JavaX persistence issues, etc., all of that, right? So how do I fix this? So I go back here on my inventory entity. Let's just close this one because it kind of creates two windows. I'm gonna do a Kai fix all, and here it's gonna go in towards the model, and it's gonna try to fetch the solution. And like all awesome demos, it is taking a longer time. But if you look at it, if I look at the code fix right now, it is trying to fix. It is trying to make a fix. It has sent the different rule sets, and what the LLM will do is come back with an output for this as well. Okay, something went wrong. Let me just do this. Like all awesome demos, something does go wrong. Okay. Okay, maybe I like memory. Nope. Anyways, so we are gonna try this again. Yes, thank you. Okay, I seem to have something going on here. I'm gonna try this again, and hopefully this time we'll have something. Okay. So here I'm gonna do a Kai fix all, and that should go in, try to get the application, but somehow it's taking a long time. And usually what it should do is that it should give me a fix of this application and get that back. And again, I see that it's giving me some errors. Awesome. Okay. Lovely to have this happening at the right point of time. To not provide an updated file. Okay, why is my LLM not responding? So what I'll do is I'm just gonna see if I actually messed it up a bit. Terminate plus ins source. I think that I want to clear. And let's see. Let's give it one more try. Otherwise, I will have to just. Yeah, it seems like the service is up and running. Let's see. And then
we're pretty good on time, so don't worry about it too much.
Okay, thanks. I'm just gonna close this just in case.
Gives it a bit of authenticity, doesn't it?
Yeah, it does. It does, and excitement, I must say that. So I'm gonna do this, okay, and I need to run my analysis. So we are developers, and now you can see how I ran the analysis, perfect timing. Add, I'm gonna go into my Kai repo and use my CLI, which is the sampled CLI that I use for doing the analysis. Then in the targets, I'm gonna select the target. I don't want EAP, I want Jakarta EE, and then I want Quarkus. And that looks pretty good, I think. Yes, everything matches. And then I'm gonna say play. And this is probably gonna take a while, like it takes about 2 to 3 minutes. You can see that what it does is in the backend, it provisions a container, pulls that container. When it pulls that container, it starts to do code analysis, and there's a couple of things that it does, and then it's generating a log file as it does that. This will roughly take about 1 to 2 minutes before it gets in there. But if there are any questions, I can field questions in the meanwhile as well. As soon as the analysis is done, then we can get back.
There's so far no questions coming in the interface, which is kind of depressing. But I guess people are just fascinated that you use Visual Studio Code and not like any other big IDE like normal Java developers do.
Yeah, that's a very interesting question. I just recently moved to VS Studio, so I'm a struggling Java developer just like all of you. So it is nice. I mean, IntelliJ is probably the best. I'll just say like that. That's my opinion. Obviously, I'll just say like this. I'm just trying VS Code. It's easier for us to kind of test it on. So just using it for that purpose, and it's easy to demo on as well. I think. Nothing taken from IntelliJ. I think if I'm doing development, that's exactly what I would use mostly. For demos, I use this. So, well, no love taken from VS Code either. Okay, so here we have the incidents. Again, we can see that. And hopefully I'm able to run this because I've run this like 10 times before and it's never failed. So this is the fun part. And I see that something's going up, which I have no clue why it's doing that right now. It's not able to connect to my backend large language model, which is fun. So processing incident batch 101, element did not provide. Okay, well, I cannot wait for this guy. So what I can do is that, let me see. I have to think of something, right? So, yeah. So what we do is, I think what we can basically do now is I'm gonna change my branch. And basically what it would do is, for example, and I'll just manually show this. I really don't know why my backend LLM is not responding. I'm sorry about that. That was not part of the plan, but it happened. And it happens all the time. And I'll link a video that I have also recorded, so you can look at the demo if you're really interested. In any case, the idea is
we can fix it in post-production and just make like dinosaurs in the background and stuff and make it really look cool. So not to worry. This is live, and this is really live, and thank you so much for trying to soldier through to it. But let's get moving on with the rest of the thing.
Let's do that. Yeah, let's do that. So basically here you see like the incident first was, hey, Jakarta E. So it's able to do that. It's basically changed all of the code that was from Java X to Jakarta. So that's nice. It does that. Then what I also want to show you, and I wanted to show this live to you, is that if I go on inventory notification MDB, right? So inventory notification, here we go. My LLM doesn't respond. Thank you, sir. Anyways, so in inventory notification MDB, what it does was that it was using JMS, right? So JMS is a different sort of code, and it has removed all the JMS naming, all of those different annotations that JMS was using, and it has moved on to something called small I reactive. So if I look at the incidents on this one, I can see that, hey, there's a JMS rule that we had which said references to JMS elements should be removed and replaced there with Quarkus small RAI microprofile, right? And so what we do when we do this from a static code analysis point is that when you send this to the large language model, it gives in all the rules incidents like I showed you earlier, and then it also kind of gives it a bit of hints. So each line that is being changed, it's able to provide that context and say, okay, this is how the code is looking, and this is how the snippet is, and this is what I want from you, right? So it gives you, in the end, an entire patch. Here you would see that it uses incoming. This is a small RAI thing, as well as all the other annotations that Jakarta has as an example as well, right? So you're able to convert from one way of using a technology, which is GMS, into a reactive messaging, which is totally different, right? So from going from a blocking call, you can go into a non-blocking call as well. So it gives you that possibility as well. Then if I look at the shipping service was actually an EJB that was being used. And what we've done with this is that once this is transformed, it goes into, let's say, a REST API. So here, if I look at the incidents, it says, okay, I have incidents like, hey, Java X2 Jakarta, and then there's a rule which says remote EJB should be changed, right? So let's take a look at it if it gives us the details. Remote EJBs are not supported in Quarkus, and therefore it must be removed and replaced with REST functionality. So we've sort of like given all these hints into the large language model, and what it does is that it then comes back and converts that entire EJB into a REST endpoint. And this is also extremely cool because, again, you're changing from an IOP style protocol to a REST HTTP style protocol, and it's able to do that for you using a large language model as well. Now, in traditional style migration tools, you would write a rule for doing the static code analysis, and then you would write rules and other expressions to actually do the overall migration. And you need to be wary of how you want to do it, and the context is much more limited. Here, you get the static code analysis done, you throw the hints over to the large language model, and we use the quality of large language model, which is generation, to give us that specific generated style code that we want from it as well. So we don't have to kind of do all that handiwork that we did before in other styles of tooling, right? So it kind of gives us that option as well. Then finally, the shopping cart order processing is also another example where you have maybe the GMS also. And here, let me just close this and kind of make this bigger for you. So if I look at the shopping cart order process, again, this is a broadcaster. So here, it also converts the part where the component was emitting a message when a shopping cart was receiving orders, right? So it was able to broadcast and say, I have orders. Using GMS, again, that specific client code has now been changed to this as well. So it does that too, and enable to convert all the other aspects like Java EE to Jakarta, from simple GMS to reactive messaging, etc. It's also able to do that as well. And then finally, I think if you look at things like persistence XML, it does not exist anymore because you don't need persistence XML in something like Quarkus. You don't need the beans.xml either, so that's also gone. It's no longer inside the system. And then finally, the pom.xml has also changed from the Java EE into the Quarkus kind of thing, right? So it's able to get into that as well. So if I for example, now there's some benefits of using this, but let's say if I simply just show you the application, I will just say mvn quarkus:dev, and now I'm able to run the application using Quarkus as an example. Perfect. So I have an exception. It's a day of exception. I kind of think I know what this exception is. So I'm just gonna say Control-C. I'm gonna set my Java build, and then I can run my application. And hopefully this runs, because I think I have had one incident already, and no, it doesn't. And I think I have some serious problems with my machine today. Okay. This is fun. Okay. Okay, something is happening this time. My compilation was not good. Okay, that makes sense. We go back, and here we will go to our app, and if I load the app, it will basically have my cool store app, right? So this is interesting. This was a monolith app, which is now converted into Quarkus. It is using an extremely old UI, like I think it's Angular 2 as its legacy stuff. And here I have my cool stuff store with all the nice gear that I want to order, right? And then it's able to look at it. But if I go into the Quarkus dev console, then I'm also able to see, like, because like originally in my other example, in my Java example, I would need to provision the database, restart the machine and everything. Here you can see that it kind of has a test container integration. It automatically starts off a Postgres SQL container at the backend as well. It gives me all the details of the extensions that I have, etc. And then I can add extensions like extension for OpenShift and deploy this on top of OpenShift as well. So multiple things that you can do once you go into that paradigm. I'm really sorry that my LLM kind of hicked up. Whatever configuration there is, we're going to get back to it. But in respect of time, I'll go into what we've actually done, right? So we had the simple cool store app, which is a Java EE app. It has its issue. It had components inside. So even though it's a monolith, it has these components structured inside. It had services like inventory, catalog, cart, orders, payment, etc. We sort of ran through the analysis, and large language model would give us the result of the generated code. And in our case, we basically just saw the results rather than actually calling the large language model at this point, right? What we do want to do in some cases is like, hey, we want to migrate over to microservices. And when we do that, obviously we divide the code, etc., and we do that. But in our case, we really did not do that, right? So what's very important is that we migrated from Java EE to Jakarta EE and Quarkus. We migrated from JMS to reactive, EJB to REST, etc. Removed the code that was no longer necessary, like a REST application.java or pom.xml or beans XML, etc. We removed all of that, right? So essentially, if you read between the lines here, it took one monolith and packaged it into a new framework with a new monolith, and that's the Quarkus monolith. So what do we not do in this? We do not re-architecture this. We do not do separation of concerns. We're not doing domain-driven design or functional event-driven. And there's a reason for it, because those things demand skills that you need to understand how you want to divide your domain. An LLM could give you some ideas, but doing that is a much intrinsic sort of thing that you need to do, because you are business driven and you want to make sure your application behaves to the business requirements that you have as well. Other things that you might want to do is look at process and automation and DevOps to make sure, when you go into a distributed architecture, you could do that. You can decide to have an event-driven architecture. So what Conveyor does is it doesn't go into that design and architecture phase, but it actually just does simple X, A to B, for example, and gives you the possibility to kind of refactor furthermore and redesign as you go along as well. And that's the whole idea of Conveyor. So simple recap, what differentiates this approach from something like a clone of chatbots or generative predictive code, for example. It is structured migration. It is purely driven by the idea of static code analysis. This gives you the feasibility or option that you can say, hey, I do not want to use log4j anymore. Use this other library for this, or attach distributed tracing, or do this based when you see such things in my code, right? So you're able to create your own rules and you're able to run those rules. But then when you throw those rules into the large language model, it is able to give you the code back using the power of Kai, which is Conveyor AI, which kind of does this in the backend while taking your incidents and meshing all the knowledge that it has about previously reported incidents as to how it wants to get you the code, right? So it doesn't change your business logic, but it changes how your artifacts or your technology is looking. And obviously, once you have that, it gives you a patch that you can accept or reject. In our case, we saw all the accepted patches, so we were not able to see the screen where it actually shows you that that part of the functionality as well. You can also extract patterns if you wanted to, and then have the possibility to do that as well. And finally, it is model agnostic. So you can use the models you want to use. You can run, models on Kubernetes like OpenShift AI or through Hugging Face, etc. And you can use them to point out to and use together with Kai. The other thing that I might just want to tell you is that what we're also working on in the upstream community, and if you're interested to talk further about it, is that we are now going towards an agent-based workflow where we are doing multiple things, like, for example, applying code patches, compilation, rerunning of errors and analysis, and a bunch of other chains that you'll be able to kind of do through agents. So if you have cool ideas and you want to come in and contribute together with us, then join us at the Conveyor.io community, and I will leave the details with you as well to do that. We are expecting to do a community release pretty soon, so you'll also be able to try out this feature as well. And obviously, it's a bleeding area. That's why I probably got a little bit of hiccup as well, which I will definitely make sure that we have some follow-up on as well. So what if you want to contribute? What if you want to learn more? And what if you want to talk to some of the engineers and understand? You're welcome to join the Conveyor community. The QR code gets you there. We have community meetings. We have mailing lists. We have Kubernetes Slack. You can join us on, etc. And the whole idea is for us to create a tool that makes modernization simpler and faster, and you don't have to spend tons and tons of money or incur cost to actually do this, but be able to actually do it in a developer flow rather than a chatty flow, as an example. Finally, my details. Thank you for listening. And if there's any questions, I will take them right now.
Oh, yeah, I love the call out to community, because being an open source guy myself, I'm like, yay, let's do our all new open. That's pretty good. We have one question, which is what difference Conveyor, not the AI part, from SonarQube? And I think it's completely different letters, first of all, the two words. But what else is the differentiation between the two?
I think SonarQube is great at what it does, when it comes to, as much as I understand, from a security perspective, from analysis, etc. What obviously Conveyor is from a static code analysis point, is doing the static code analysis. And you have multiple tools that do static code analysis the way we do. What we are really focused on is actually the part that you said I should tell you not about, which is the large language models, right? Mesh that two together. And I think if you look at different things, you have SonarQube, you have Open Rewrite, so you have recipes. What Conveyor does is it gives you the static code analysis. It gives you hints on how you can fix them, without the LLM I'm talking about. And then it's also able to give you story points in terms of costs, etc., that you might incur to actually fix this. So it's an iterative process. It goes through it. SonarQube has its own way of doing it. Open Rewrite has its own way of doing it. But I think the next frontier really is, how do you mesh this generative technology? I'm not saying AI right now, because some people feel like a little, about it, but the generative technology, just from the way it is, that it gives you all this code that you can generate, how can you tame it, control it by the way what you've done with the analysis? And I think that's where Conveyor is standing out at this point.
Mm-hmm. How big is the community? Like, how much do you get from outside into your world, and how many people are? What's the fluctuation like?
So it's a very new community. I think it has been there roughly, I think 18 months, 2 years, or something like that. It was spun up by IBM and Red Hat, and then there's other contributors as well. So it's growing. It's not like the biggest community on the planet. It is growing. It's relatively new. So I think that's how you should see it. And the excitement is there, like any other startup community. And I think you should join the excitement.
Cool. What are you looking for, especially? Like, I mean, the problem that I found when I ran communities or I started communities was always like, people felt they're not good enough. They don't have anything to contribute. Like, what are the big needs right now that you're looking for? Is it questions? Is it ideas? Is it features? What do you want from people?
Actually, anything. I think we really value, like, all our engineers are hands-on into Conveyor, the static code analysis, the LSP, the large language model, everything. So we have a lot of expertise there. And what we always appreciate is the domain expertise. We've had customer requests or somebody just meeting up and say, hey, can you change my RPG code into something different like Java or Rust? Could you convert my COBOL code and etc.? So Conveyor is not just about Java. Conveyor is about any language. So anybody who has understanding of languages and different paradigms and has experience and can even tweak rules or ask interesting questions, we welcome everyone. I think we at this point are like we're going at a speed of light, if that's even a term. And what we're doing is we've created these rules and this rule engine, and then we have this whole mesh with large language model. If somebody comes up and says, hey, I have this cool idea about how you can migrate X to Y, and this is how it works between these languages, I mean, that's where we're heading. So we have a lot more years to go in terms of all these different languages and models, and we just start with Java at this point. So any ideas, we highly appreciate that. Join us on Slack, throw your ideas. You want to make a contribution, there's a whole rules engine, rules repository. You can contribute there. There's a whole guideline to it. Go on Conveyor.io. We have GitHub as well, so you'll get a lot of information. And if you want to reach out to me, I mean, feel free to reach out, and I'll make sure you're connected as well.
It's a huge market, isn't it? I mean, when I looked around, the amount of this year, a lot of engineers that worked on COBOL, Fortran, really these old languages are all becoming pensioners and basically leaving the market. So there's a lot of insurance companies, banks, and those people are basically running against the wall of who's going to maintain that old mainframe code that we have right now. And it's either really expensive freelancers, or it's basically a way to find an opportunity to actually modernize these things and convert them. And I think that's why we in the AI space, we're not thinking about too much about that. We're getting too excited about generative AI, creating new products rather than fixing old products. So thanks very much for that. Also great that everything went wrong. It's horrible as a presenter when that happens to you, but it shows that's in the making, and it shows that running a model on your machine, no matter how fast your machine is, it's always a dangerous it's not dangerous, but it's a tricky thing. One last thing, it's you said one of the bits at the beginning when you said this was an insecure piece of code. Is there a way to actually automate that? GitHub Copilot, for example, just now is aware of the GitHub code security announcements. So basically that is always added newly to the model, not to the model, but on top of the model. Is this something that you're also looking into, or is this, I mean, that's the first thing that I did with static analysis is finding mistakes, finding syntax errors, but also finding security holes.
Yeah, exactly. So with the whole, this approach is you don't have to go to a language model vendor to tell you hey, there's a CVE here. You can take it up, you can write the rule yourself, and you can do the analysis, and then you can point that out to Kai, and Kai is going to make sure that it can give you a fix for it, right? So it is an iterative process sometimes, but yes, it's able to do that. It's able to look at your annotations, your line of code, your import statements, your functions. It's able to look at all of that. And by having this data, I think what makes me excited, if I put it like this, is we're not just chatting to a model and telling us to give something, and then it doesn't give us something, and then we tried something else, and finally after 10 different discussions we get something, right? Kai is doing that in a very sort of a very nice process where it actually takes that static code analysis and then meshes that, right, and then gives the hints and ensures that you get the output out of it. So now as a user, as a developer, what you're looking at, and an architect, etc., is how can I quickly create these rules? I already have these bunch of technologies. They look cool. Yes, Java E2 Quarkus and Spring Boot, etc. Awesome stuff. But I have my code on premise, and I know these things exist, and I can change them. Or there was a new CVE that I picked up. So let's do an analysis and see where this exists. So you're able to put that into your pipelines and actually take that out, and then go through a process where you can refactor it using the generative component. I think that's the exciting business. I think that's really out there.
It also helps companies that cannot use other third parties, but have to do everything on premise, like banks and insurance companies and those people. So That's the interesting use case there as well. Well, thanks so much. We have to move on, sadly enough. But I hope you can now go back to your machine and fix all the problems, and then show us in a 5-minute video that it can be done. But you already have one already, so we're good with that. Thanks so much again for your contribution. Again, the video will be out. You saw more than one opportunity to contact Syed, and then we go from here. Thank you very much.
Thank you very much. Have a great rest of the day.
And we move on to the next speaker, which is Vadim Kazulkin. I hope I pronounced that right. And he's going to talk to us about high-performance serverless Java on AWS. And that's an interesting topic. So let's get Vadim on stage and his slides too. How are you doing, Vadim?
Yeah, I'm fine. Thanks. Can you hear and see me?
I can hear you. I can see you. You brought the right headphones to land a helicopter or give a presentation, so we're good.
Yeah, then we are probably good to go.
Excellent. So let's talk about high-performance serverless Java on AWS, because Java's got a bad reputation on serverless, doesn't it?
Yeah, I can confirm. Yeah, it has reasons which I will be talking about, and I think AWS is not an exception. It's just the same for other cloud platforms or even self-managed Kubernetes, where you have Kubernetes and other stuff that we call serverless there. And yes, but of course, Java has a huge community and huge potential. So it's time to change the things. And there are already technologies or approaches there to at least improve the stuff. And that will be the topic of my talk.
So let's change our minds. Thank you very much. And I give over to Vadim.
Okay, then thanks once again for the invite to talk about that. I would say the topic of my research, a high-performance serverless Java on AWS. And yeah, my name is Vadim, and I have these two passions, Java, and I'm one of the co-organizers of the Java user group Bonn, where I live. I live near Bonn, but I'm also AWS community builder in the serverless category since 5 years, since the beginning of the program. So this is kind of crosses both topics, and you can get in touch with me via different channels. So basically, what's the motivation behind the talk? I'm very heavy in AWS cloud. Yeah, my company has a complete lock-in to at least AWS, and I started to develop Java in the end of the last century. And of course, also AWS serverless, or at least serverless, is very suited for many workloads, not for all. And of course, then the choice of Java is always, can I use Java? What will be the benefits, drawbacks, and all that stuff? And we will see that the serverless paradigm changes so many things that we were accustomed or used to use, but it's not only for Java, for other programming languages that are kind of better suited from the beginning. But if we will talk about Java popularity, it doesn't matter what ranking do we take. There are number of job postings requiring Java skills, Stack Overflow, post, GitHub repositories with Java. You will always find that Java is kind of top 3 programming language. And sometimes it's just even better. And there are rankings that Java is number 1. But, and life for AWS developer, at least, is very good. So they're offering Lambda, kind of the serverless offering. AWS offers its own Amazon Corretto. This is production-ready distribution of OpenJDK. They support the older, previous LTS versions even longer, like Java 8 will be supported at least until 2028, for good or bad. But the life is good. For example, we had to wait for Java 17 support quite a long from Lambda, but Java 21 was released 2 months after its release last autumn, and AWS will support only long-term versions on Java. So the next one will be 25. So, and in general, if we look into the people behind the Amazon Corretto, people who are kind of aimed at improving the situation with Java compilers in general, but also for the serverless applications, you see very famous names. There are 2 even living in Germany, Volker Simonis and Roman Kenke. But there is also Alexei Shipelev, who joined AWS last year. He worked for Oracle, he worked for Red Hat, and he's one of the authors of Shenandoah Garbage Collector. So there are really smart brains behind that stuff to improve the life for us. So I think we agree Java is a very fast and mature programming language. But if you look at the serverless adoption of Java on AWS, so basically how what's the percentage of Lambda functions written in Java. We have two statistics from the Datadog, one on the left from 3 years ago, one on the right is last year. So we see Java is still number 3, but the results are quite disappointing. Yeah, even the adoption increased from, I would say, 4% to 11%. It's not, of course, what we would like to see. Something just reaching maybe 30, 40% will be something where I could imagine Java. Yeah, so what are the challenges here, yeah, especially in the serverless world? So basically, as it's not AWS conference, we'll do some basics how you can create Lambda function. It's basically you select runtime, in that case, Java 21, there are Python and so on, but it's a Java talk. And what you only give is just the memory assigned to this Lambda function from 128 megabyte to 10 gigabytes, and you will get the fraction of CPU depending on the memory. For example, the full CPU access will be given if you select 1.8 gigabytes of memory. So basically, if you select only 1 gigabyte of memory, you will have only half of the CPU cycle. That will be important. So I will show you one of the examples of such Lambda function, but what are the challenges? First, the call starts for latency sensitive application with public API. I would say the users waiting for the response. If the application is basically completely asynchronous and not public facing, it's not so much the challenge, but of course there is also memory footprint, because the memory selection, if application consumes more memory, it's one of the cost dimensions on AWS, how the Lambda is priced. The next one is the duration of the Lambda function. So let's talk a bit about the challenges. So once again, Lambda, the serverless offering where write kind of managed Java with managed Java write applications, it's function as a service. And it's different from infrastructure as a service, container as a service, platform as a service, that one container, one environment is only capable of executing one request in the time. And then this environment simply goes back to the pool of the warm environments if it's ready, and is then kind of ready to take another request. So what's basically the life cycle of the call start? So the request comes to the Lambda API, and if there is warm execution environment available already, it can be used. If it's the very first request for the Lambda function, or you change the code, then of course new environment needs to be created. We will see what does it mean. So that the compute should be found, the code should be downloaded, and all that stuff. So, or there are, for example, 5 warm environments ready, but you have 7 requests in parallel. So we will need 2 additional ones to put on stage. And this is kind of what happens. If you need a new environment, then there is a cold start. And of course, these warm environments, if you don't have traffic, the AWS will release them, will kind of delete the environments because it costs them money, and they also release them for the sake of patching anyway. They patch operating system, they patch Java versions, so there is no environment staying forever, even if you can use it. Yeah, then there will be kind of new, fresh environments. So in case of Java, what does it mean? AWS has its own offering, Firecracker Micro VM. This is the execution environment and also orchestrator around it. That's similar to Docker, but AWS has its own one. And in case of we select Java, then AWS Lambda starts the Java runtime, and then the Java runtime loads and initializes the code, especially in the static initializer blocks. Class loading, session initializer block. If we'll use something like Spring just-in-time runtime dependency injection will happen. Of course, in parallel, just-in-time compilation will kick in. And these steps are cold starts. Download your code, execution environment, and this is static initializer block. And the execution of the function handler itself is the last step, and it's called the warm start. So if the environment is there and can be used, you can only have warm start. In case we don't have the environment ready and one needs to be started, you need to go through all these steps, and the first 3 are cold starts, and we will see what the impact does it have on the performance. So this is kind of the example of simple Java function, a Lambda function that we will use, get product by ID. And that's basically what happens in the cold start phase. This the class will be loaded, static initializer block, this is product DAO will be loaded, and everything recursively. What will not happen is the execution of the handle request method, which is the Lambda business logic itself. This is the warm execution. So, of warm start. So I will show you some demo application which is purely serverless. Basically, we have API gateway on the left side, and we have a bunch of Lambda functions, each responsible for single job, like creating the products, updating the products, deleting the products, getting the products by ID, and it's stored in the pure serverless database. I will also mention several words if you are using some relational database in the end, but this is kind of the pure serverless AWS world. So I will give as a starting point this Lambda function 1 GB of memory. It uses x86 architecture, that's the default one. If you talk to DynamoDB, this is HTTP based database. You're making calls via HTTP. So for that, we will be using HTTP client. The default one is Apache. This application with all the dependencies to AWS SDK has 18 megabytes artifact size. And we will use that a bit complicated Java compilation option that produces the best trade-off, one of the best trade-offs between warm and cold execution times. So I measured the cold start for approximately 1 hour, and then I had 100,000 warm executions. And that time, it produces 100 cold starts. I simply put a bit stress test just to have multiple containers needed just to be started, execution environments that produces the cold start. But your pattern might be different. I only have here the ratio of 0.1 cold starts. You can have several percent. And that's normal. Yeah, your pattern will be completely different. So we will see this picture for the cold start measurements, this for the warm start measurements, and let's measure the cold starts for that experiment and give you the results. So first of all, you see the results are in milliseconds, and you see here percentiles. So like P90 means that the warm starts are in 90% the cases below 7.8 milliseconds. So what first we see, Java is really quick programming language. The warm start execution time of the Lambda handler itself is, I would say, up to 90 milliseconds. For P90 is even 7 milliseconds. We have this one outlier that I will explain, the max value, but if we'll be looking for this very simple application with not too many dependencies on the cold starts, we see here like P90, these are additional 3.2 seconds, and this might be significant. And especially because the latency, it's not the whole cold start and warm starts of the Lambda function is not the whole latency. Latency is this amount takes from when the request is made by the user to the time it takes for the response to go back. And basically, Lambda cold start for this kind of application and warm starts are only part of the game. So you have here client, which is sending requests to API gateway. This involves DNS resolve and SSL check, handshake, and API gateway also needs to process requests. Then you have this Lambda cold and warm start times. Then API gateway need to process the response, and then the client need to process the response from API gateway and then show somewhere, like if you're using browser, the browser results. So other steps may also add several 100 milliseconds to that picture, and so the total latency might be 5 seconds or something like this. And this is in case of the cold starts happening, and it is a bit too much, or might be a bit too much for your application. So what options do we have? I will basically be talking about two of them, AWS own offering SnapStart, but also GraalVM native image on AWS Lambda. So yeah, this outlier, we will be looking into this once again. So let's start with the SnapStart. I wrote a big article series on Dev2 where I explained my experiments and the impact of different settings on that, so you can read this. You will see the link to this in my slides, or the link to the GitHub repository where you can simply check out and run your experiment. I'm now in the part 24, something like this, because there are so many things that needs to be measured and trade-offs to be made, and I will present you only several experiments here. So once again, what's the SnapStart? SnapStart for Java application can improve startup performance, and this is the same as startup time. Yeah, cold start, startup performance for latency sensitive application. And what's important, SnapStart is fully managed. What does it mean? You decide on per Lambda function, would you like to have SnapStart or not? And this is basically checkpoint. It's one line more in infrastructure as a code, but basically you say, I would like to have SnapStart or not. And it's currently available only for Java managed version. So the name SnapStart doesn't include programming language, but currently, and since the release during the reInvent end of November 22, where Java support was announced, there have been no other programming languages that support that. It can be interesting for C# as well. But this also means it's not available. You can deploy Docker container images on Lambda as well, containing Java application, but you cannot use SnapStart for this. And the same is also for custom runtime, the way to ship GraalVM native images, we will see. So there is no SnapStart, but for the last one, GraalVM native image, it's even not reasonable to have. So what happens with the SnapStart? So let's imagine you decided to activate SnapStart for your Lambda function. Then SnapStart will kick in two different phases of Lambda function, kind of. The first one is deployment phase, and obviously in the invocation phase. So what will happen if you activate SnapStart in the deployment phase? Normally, if you don't have it, Lambda will simply be deployed. But in the case of SnapStart, the whole call start phase will be run through. So the start of Firecracker VM starts, Java runtime starts, the code of the Lambda function will be downloaded, and the function will be initialized, the static initializer block. Of course, the function will not be invoked itself, but this call start phase will be run. There is an optional hook. We'll tell several minutes later about this. And then the create snapshot will happen. So what's the snapshot? Snapshot is the Firecracker micro VM snapshot. And it's different from Creo, Crack. If you heard about this, these are comparable technologies, but AWS does its own stuff. There are differences between Crack and Creo and how Firecracker snapshots that. And in case of invocation happens, then the snapshot will be restored. And we have after restore optional hook, and then the function will be invoked. So basically during the deployment phase, the live traffic is not impacted. So the function will be considered as deployed after the snapshot is created, and only then the version of that function can be invoked. So this is the first thing. Now let's talk about these optional hooks. So Lambda uses Crack API runtime hooks, but Firecracker VM doesn't rely on Crack. It's similar technology developed by Azul people, and there are Crack-enabled JDK. Amazon Coretta is not that. They only use API. So what can you do with that Crack snapshot hooks, especially with that snapshot hook, which will be invoked prior to snapshot? The technique is called priming, which says preload as much as possible, pre-initialize, so that as much as possible goes to their snapshot. What I'm showing you here, that's the details of the method that I had to implement, get product by ID. Yeah, and the product will be retrieved from the database. So, and if this invocation happens, there are things that we know. For example, even if I don't set here HTTP client, the default one is Apache one, and it's known that Apache HTTP client is designed for long-living applications like those in Netty or Tomcat, and it requires several hundred milliseconds to be one-time initialized for the life cycle of, in this case, Lambda function. It takes time. The second thing, what happens if I retrieve the item from DynamoDB? DynamoDB stores JSON data. I have Java, yeah. So this needs to be marshaled, unmarshaled, or serialized, deserialized, depending whether you are using, where reading or writing stuff. Also, one-time initialization phase of the JSON marshal I used below is also something time-consuming, also consumes several hundred milliseconds. So the idea is here that I would like to invoke this method in this snapshot hook. And what will happen also, all these classes here will be also preloaded. Yeah, they are not part, they will not be loaded with static initializer block because they are not used. Java use dynamic class loading in this case, or lazy class loading. So all that stuff beyond all this kind of chain of classes involved in this invocation chain, everything will be also loaded. So this is basically how this priming looks like. I implement resources interface, which requires an org Crack dependency. I need to initialize this get product by ID Lambda function as a Crack resource, simply copy this line of code. And basically with the resource, I have two methods, before checkpoint and after restore. And in this before checkpoint, I'm simply do the invocation get product by ID 0. I'm not even interested in the result. I'm interested in the pre-warming stuff and loading bunch of additional classes into the snapshot. So now we talked a lot about that. So there is also the guide from AWS how to create priming. There are, depending on the application, different things that can be primed. There are applications that you cannot prime, something like hello world or string concatenation, not too much that can you prime, but most applications are a bit more complex and you can prime. So now I talked about the stuff, let's measure. And what you see here, these are the measurements that I have already shown you for the cold start. With snap start not being enabled, this is done. These are the measurements with snap start being enabled, but I intentionally didn't apply the priming. There was also additional code to be written, and this one is with priming of DynamoDB invocation. So if you look at, I would say, in this yellow one, P90, the cold start went down from 3.2 seconds to 2 seconds only by checkboxing and say I would like to use snap start. If I apply priming, and I can prime, and for this particular case, the P90 cold start is down to 1 second basically, and this is a huge 70% lower. You can deal with that. It's significant improvement. So the warm starts. Once again, snap start is not the technology to improve warm starts, but what is interesting, the max value went down completely. Why? Because as I did not activate snap start, I didn't apply priming, during the cold start phase, so the new environment, of course, the Apache HTTP client needed to be loaded. Jackson Marshall needed to be preloaded, all the classes that happened also during the function invocation. And that's why the invocation, also the warm start, in case you experience a cold start, can be longer because all the things are not there. And in the case I applied priming, I already pre-initialized and put that into the snapshot. So also the max values went down. Yeah, and this is important if you measure the cold starts. Also look into the warm starts. In that case, they can be also longer. Or you can also apply priming, making this fake call in the static initializer block. It works as well. Then you will have bigger cold start and less warm start. So basically, this was the initial experiment that brings down cold start time to something that might be already acceptable. I would like to show you some other stuff. For example, you can play around with memory. So once again, if you double the memory, you also double the CPU. Yeah, and with more CPU, you can improve significantly performance so that the cost will be in balance. And I simply measured the cold starts with different memory settings. Here is without snap start. And you see, basically, 1 gigabyte of memory is a very good trade-off. If you give less, you have higher cold starts. And if you give more, this it's not significantly how they go down. The same is basically also true with snap start, but without priming. I also think that 1 gigabyte for that use case is acceptable, and many say something between 500 megabyte and 1 gigabyte is a good setting. It's more interesting if you apply snap start with priming. You see that maybe you can also give less memory because the results are a bit more close to each other, and by giving less memory, you also save on costs. So the morale here, do your own measurements. Another dimension which is important is the size of the jar file, of the Lambda function with all dependencies. It's of course known prior to snap start. The bigger the application, the bigger the cold start. That's the code needs to be downloaded, the more time it takes, but also a bigger package tends to have more dependencies. And that's why there also needs to be initialized. I wanted to check if that's true, if I apply especially snap start, because it's basically gives the possibility to quicker restore the stuff. But it's still true. You see, I have small Hello World application, which nobody writes with. This the red one where even snap start is not what we're doing. I have this medium size 18 megabytes application that's mine. And I also wrote some bigger ones with more dependencies. And you see, the bigger the package, the more the call starts, even with snap start. The differences might not be too big, but you see, it's at least paying attention what you put as a dependency. So use only dependencies that you require. don't put any dependencies to test stuff. It might not matter for long-living application. It matters a lot for short-living applications like Lambda. So there are other stuff as AWS specific. You can use so-called Lambda layers. And with that, what you can do is to package your common dependencies. If I have a bunch of Lambda functions, they are all talking to DynamoDB. I have the same dependencies with the same versions. And I can put them into the Lambda layer and then simply reference this Lambda layer. Don't package them with each function. With that, the function deployment will be kind of quicker because the package itself is smaller. I wanted to test out what does it mean for the performance, especially for the cold start, and also found out that using Lambda layers, the cold start went a bit higher because Lambda layer needs to be mounted. And also the things needs to be pre-initialized, and then the dependencies needs to be put into the class path from another location. But you also see that with the snap start and priming, especially, the difference is really not really visible. So it might be the case it's worth doing. If you cannot apply priming, you see that the difference is just about 400 milliseconds and it's too big. So be cautious, measure it also for your use case. Yeah, this one is also very interesting, which turns everything upside down with Java compilation. Probably everybody know how it works. And that basically there are 4 levels. I mean, nobody will use probably interpreter level, but there is C1 client compilation, C2 server compilation. But basically what the thing here is that compilation costs time. It requires the thread doing the stuff. It takes then CPU. And for example, with more profiling, you can only benefit after the certain number of invocations has been made, and then the optimization took place. For example, as far as I know, for server compiler, in order to optimize the function, it should have been invoked 10,000 times. It's not very clear if your Lambda function will be invoked 10,000 times before the container execution environment will be released. So it questions many things. So we need to think, okay, maybe other compilation options will be good one. And default one is for Java 21 is tiered compilation, which is best of 2 worlds. And you have the possibility to set the environment's variables and set the concrete stuff here, concrete compilation options. So basically, I tested with them. The default one is tiered, the red one, there is stop at level 1. So we optimize only a bit, or stop at level 2, and so on. So basically what I found out, the worst results are basically with server compilation, and the best results are with default one, with tiered, or even with that I use stop at level 1. It's only basic profiling. Yeah, it depends on your use case, and also measure, because sometimes it's you have with stop at level 1 better cold starts, but a bit worse warm start compared to tiered compilation. So it depends on what's your trade-off here as well. And for the warm starts, as I told, it's a bit different picture, but these two are very close to each other. For the default use case, I prefer currently stop at level 1, but sometimes the default one where I don't need to set is also good. So I also tested with different Java garbage collectors, and also nothing needs to be changed from your side. The default GC G1 or G1st produces by far the best results. I couldn't even imagine that the difference can be so big, but I tested with the parallel GC. Amazon Corretto also offers open source Shenandoah GC, and I found out that the difference in call starts can be up to 200 or 400 milliseconds. I could not make Lambda work with GDC, generational or not. I need to look into that, but maybe this is something for bigger memory, and if I give only 1 gigabyte or less, maybe GDC is not the right use case anyway. One thing you also need to pay attention, as I told you, if you talk to DynamoDB, it's about connecting via HTTP. And if you don't set explicitly HTTP client, it will be set, but the Apache HTTP client will be set by default. And AWS offers integration to URL connection HTTP client, but also AWS own AWS CRT HTTP client, which is in 2 flavors, synchronous and asynchronous. And this one from AWS is written more for short-living applications like serverless, because Apache is more, once again, for long-lived application. URL connection basically the same. So you need to add it as a dependency, and you can make your own measurements, especially for the cold start. It's really interesting. Yeah, you see that AWS own one, which is written natively, outperforms in many cases here even significantly if you don't use snapstart, but even with snapstart without priming, it outperforms. When you use priming, you already primed initialization of the HTTP client. It doesn't matter what you selected, so the results are quite close. But this one can be used if you connect to the outside of the world from your Lambda function to some HTTP, some third-party web service. Then you can use it directly. It really shrinks down the cold starts. AWS also offers, you can also connect asynchronously with a synchronous HTTP client to DynamoDB. There is this AWS CRT asynchronous one and NATI. This is a whole different topic. Would you like to work asynchronously because you will not have the results directly, but completable features? So this whole paradigm of asynchronous programming, it's up to you. I measured this. There are links also in my talk. You can look into this, but basically many of you will maybe prefer to stay synchronously. And AWS releases also kind of decision matrix, what client you can take, because they offer different level of configurations, and HTTP client Apache is more configurable, sophisticated, and I only tested with default configuration, which might not be the right for your use case. So it's not only about cold starts, but you can play around with configuration, connection timeouts, and all that stuff. Okay, there is one more measurement I would like to show you. So previously, you can select different hardware architectures for your Lambda. x86, and since several years ARM 64 architecture with AWS provides their Graviton-based instances on ARM architecture. But the thing was, 2 months ago, the snapstart was only supported for x86, and that's why snapstart outperformed with x86 all ARM 64 measurements. But now the support was released, and of course I wanted to test what's the promise here. ARM architecture costs 25% cheaper. Yeah, so memory duration here is 25% cheaper, and that's why you can look into the result, what it will bring you. So I measured the difference between x86 in red and the ARM 64 in green. The cold starts, you see the difference. It's, I think, only P90. Without snapstart, it's 8% more. With ARM architecture having snapstart activated and priming, the difference is 25% slower ARM architecture. But for the warm starts, the difference is way below. For that particular use case, ARM architectures are only have bigger warm starts between 9 and 10%, something like this. So what information does it give you? You can give probably more memory to your Lambda function with ARM architecture, like 10% more, and you will probably have comparable cold start times and warm start times, but giving 10% more memory, which is 25% cheaper, can save you on costs. So this is something that you need to test for your use case if it will be worth doing, but in many situations, it might be the case that ARM with snapshot support is a very good choice. So there is one more magic that comes in. I measured the cold start for the first 100 invocations of the Lambda function. So I changed the Lambda functions and measured then the cold starts right from the beginning. The situation is, of course, your Lambda function may run years without any changes, so you will experience many cold starts. Why I'm talking to this, there is a magic called tiered low latency cache where the snapshot is stored. It's encrypted, stored in multi-AZ fashion. So each region in AWS has multiple AZs and it's stored multi-AZ fashion in this low tiered cache. The thing is, many enable snapstart test one cold start and say the results are big. But the magic happens if you experience the second one, then the cold starts went down, and then it went down, and after 10 or 15 invocations, you see numbers that are really lower. And this is this tiered low latency cache, which is not filled right from the beginning. So the first invocations are always slower, and then the cold starts. Then the cache will be filled, and then the results are better. I wrote about this also in my article where I explored this because I was first a bit puzzled, and then I asked questions to AWS people. They explained me, and here are the results. If I measure the first kind of 100 cold starts, let's look here with priming, and only the last 50 of them, then there is a huge difference. Yeah, there is only P90 700 milliseconds, and here 1 second. So the first of them are slower, and they went here into this percentiles. But of course, what are the first 10, 20 invocations if you may have for the whole life cycle, thousands of them, and the cache is pre-warmed, snapshot cache. So here, so the real results are even better. What I wanted to say, if you pay attention to this tiered cache. So basically, also SnapStart has its limitations. Deployment of with SnapStart takes about 2 and 2.5 minutes because the snapshot needs to be created, encrypted, and stored in multiple AZ fashion. If you have multiple functions that you deploy in parallel together, then the snapshot will be taken in parallel, so not too much impact. Snapshot is deleted from cache if Lambda functions is not invoked for 2 weeks. So it's not a very good case for test environments. They might not invoke it. And in case you invoke such a Lambda function after 2 weeks, you will have error, and then the snapshot will be created beyond the scenes, which takes 2.5 minutes. You will experience errors 2.5 minutes. I personally would prefer normal cold starts in that instead of errors, and then the snapshot is created, then kind of switch back. I put it as a wish, but let's see. And SnapStart doesn't support provision concurrency. If you just would like to pre-warm environments and pay for them, it doesn't support NFS-based system, elastic file system, but I mainly use S3, so it's not a big problem. But once again, there are some limitations here. So once again, I can recommend this talk really highly because Mike Danilov talked at KubeCon, I think last year, about AWS Lambda under the hood, and he talked about how they implemented SnapStart and how exactly this snapshot tiered cache works. It's really magic because you can imagine your Lambda function can live for years without the change, but the environment will change. Firecracker VM will be patched, the whole operating system where your code will be executed, it will be patched, and also Java minor version will be changed. Yeah, AWS Corretto will release other versions, and the latest one will be used by default. So, and the cache contains the whole snapshot, and they simply replace these pieces if we don't change the code, but then they simply update the operating system. They only several parts of the cache will be updated beyond the hood. It's really, really cool technology. So look into this talk. It's really amazing stuff how they implemented this, not to invalidate all the cache because of any changes, because then you will experience quite heavy cold starts. So now let's talk about GraalVM. What does it bring? And probably everybody knows what is that. And we are only interested for this talk on this GraalVM compiler, which gives the possibility to have ahead of time compilation. Everybody probably also knows what does it mean. You provide native executable for all reachable method fields and classes, and that's basically it. And GraalVM supports that. And what's the promise of native executable? Shorter cold start times because it's precompiled natively, and for the same reason, you don't have the Java overhead, or partially don't have Java overhead in between, so the memory footprint can be much lower. How you can bring GraalVM native image to AWS? It just doesn't support natively GraalVM. It's just different Java virtual machine as normal Corretto. You have the custom runtime, and with that you can deploy basic function zip, which contains of bootstrap file, and this bootstrap in case of GraalVM native image is exactly that. Yeah, GraalVM native image compiled and renamed to bootstrap file. There is a whole block how you can compile GraalVM native image. It's not to talk about this. But basically, if I measure for this same use case, then the cold start, and you see here I added GraalVM native image, you see roughly half of the second. So it outperforms by far SnapStart even with priming. And the same is true also for the warm starts. You see there's a lower warm starts, especially in the higher Ps, like P90, with the GraalVM comparing to the management that we have, measurements that we have seen before, and even max values are quite low here. So GraalVM brings the best possible results. If you of course, you can also do the same trick and give and test with different memory settings how GraalVM will perform. And you also see here, sometimes it's really worth giving less memory to the Lambda function because the cold starts are not that big. I gave 25% less memory and the cold starts are, I don't know, 10% higher. So maybe it's a good trade-off price performance. So also check it out. It's true, GraalVM requires less memory. The same is basically also for the warm starts, the same situation. But of course, it's not free, and you need to think about how to put everything that needs to be instantiated on the runtime, all the classes, because ahead of time compilation is a closed world. You need to manage this reflect JSON and put the stuff here, the things that are instantiated kind of on the fly, like the Lambda function, which is defined in YAML file, how the JSON will be converted to our entities like product. You need to put that stuff. Otherwise, you will have class not found exception during the runtime. And it brings us to the situation we don't always control our code. And the GraalVM kind of has the page there. They say what frameworks and what versions are GraalVM battle tested. And this bigger one, Micronaut, Quarkus, Helidon, and Spring are. But they also have the list of open source dependencies with their versions that are also battle tested. Sometimes we use something, dependency brings other dependencies, so it's difficult to control, but you need to pay attention because if you switch to the newest version, that can bring something that requires dynamics, and then you will have error on the runtime error if you have not tested, and then you need once again to adjust reflect JSON, all that stuff. So that's much more caution required. And of course, GraalVM is powerful, but it improves cold starts and memory footprint significantly, but of course, it's not without challenges. So it requires Linux executable because AWS Lambda custom runtime requires it. It puts immense pressure on your CI/CD. For my example, I need between 6 and 10 gigabytes to produce native image. So your CI/CD needs to be scaled. If you produce such many images in parallel, and it requires then costs on your side. Build time is a factor for the same application in my machine, between 2 and 3 minutes to build native image, so it's comparable to the snap start. They are the same stuff. The build time or compilation time or deployment time takes longer, so it impacts a bit developer experience. Some closing words. I wrote also article series, so I'm about to write several of them, at least because sometimes people are heavy on Spring Boot, for example, but also maybe Micronaut and Quarkus, and they don't use Lambda directly because of it increases the productivity. We know what advantages Spring Boot brings, but of course it brings also challenges. If it's just annotation processing and all that stuff. So I wrote the article series and I'm releasing new ones. There are open source projects also coming from AWS itself that help you also to help you to write this efficiently, that you even can partially migrate your existing Spring Boot from at least on-prem to your cloud. Of course, DynamoDB is something, it's not portable, but anyway, you can at least migrate your business logic, and DAO is a different topic. And because DAO, at least DynamoDB, is not everybody heavy on it. It's just NoSQL database, and many would like to use some relational databases. And Amazon offers Aurora, it offers other stuff. So you can basically also read my article series where I explore the ways and also measure performance using relational database, and cold starts are bigger using a relational database, several hundred milliseconds. DynamoDB is really optimized for the cloud usage, but of course with different trade-offs. So wrap up and suggestions. I will say both technologies, AWS Snapstart and GraalVM native image, reduce cold start times with Java, with managed Java on AWS Lambda significantly. If we are willing to accept slightly higher cold and warm start times, I would start with Snapstart. It's fully managed. I don't need to build some native images. The whole snapshot is taken completely managed for me. But of course, if the high performance, it's your business need, and it's about reducing the cold start as much as possible. Of course, you can use the same Lambda function, build GraalVM native image, deploy it as a custom runtime. That should work. Of course, I'm looking forward to what Project Leiden will bring with the goal of improve start time to peak performance, and footprint of Java programs kind of in the core of Java itself. I'm not quite sure how it will work with Lambda life cycle. I saw the very first measurements where the call starts are reduced by half. Snapstart can do more on GraalVM native image, but it's only the beginning. But of course, if you need to start the application, then to make some snapshot or class data sharing and then start with class data sharing, this is something that it's very good if it's supported natively by platform as Lambda. They do it in similarly with Snapstart with the deployment phase. So if Lambda will support Project Lake natively, then we will have benefits. If we'll need to do some magic on our own, I think it's really quite heavy. So I really appreciate that Snapstart is fully managed. Word of caution, remeasure it for your use case. Of course, if you have different use case, measure the results. Even if you will check out my examples and measure, you might have different results. Why? First of all, once again, I measured with a certain minor version of Amazon Coretta 21. Now there is a bigger version. Yeah, they update it from time to time. So there may be different trade-offs in the platform itself, some changes in the Java JVM that bring a bit, at least, different results. Lambda Snapstart snapshot creation and restore may be improved during the time, and it will hopefully improved really, and it will provide better results. Firecracker VM improvements, all the stuff. GraalVM, you can use the recent version, like recently 2022, but 23 will also be released. I use 21, so you can. There are some changes. There are still servers behind Lambda, so Java memory model impact other values in L caches and RAM. So you might have slightly different results. So don't be discouraged. Measure it for your use case. And this is basically it, what I wanted to tell you. I hope it was engaging and interesting. You learned a lot, and I will be happy to answer your questions.
Hello. Yeah, sadly enough, there aren't any questions. So the people basically haven't been using the chat as much as we wanted to. One of the things that I was looking at, I mean, there's lots of information that you gave us today. Did you have any information from, I mean, you've done your own like 10,000 startups, cold startups, warm startups, and did you have any information how anybody implemented the same idea and actually had an impact on their product? Have you seen it in production yet? Or is it something that people are looking at your research right now and trying to implement it into their own product?
So personally, on AWS, we don't, on IP Labs where I'm working, we started with serverless 6-7 years ago, where basically even GraalVM was in the kinder shoes. So we write a lot of with TypeScript currently. But I know lots of companies like Capital One, they are really heavy on Java and really heavy even on Spring Boot. And they put many things into AWS serverless. So the things are really used in production. That's it, especially since the Snapstart is there. It was a trigger for many to say, okay, I can now imagine, especially if the companies were in that time considering to move to serverless or move to AWS, it was basically the trigger for them to say we can reuse the stuff. Otherwise, Java had kind of this hard time. If you have this 3, 4, 5 seconds, and with Spring Boot, my first measurement as we tried Spring Boot on Lambda without any optimizations 6-7 years ago, the call start was between 6 and 8 seconds. And it was probably, many will say, no go. Yeah, I was there. Yeah, I was in the Snapstart and GraalVM native image. It will be higher call starts as without Spring Boot, but they now in the acceptable range, 1 second and a bit more than 1 second. Now you can implement more use cases with that. Yeah, that will be my answer.
So how about other cloud providers? I mean, it seems like Amazon has done quite some tooling around that issue and is aware of that issue. Have you seen something similar for Google Cloud or for Azure?
I personally am not proficient in those cloud providers, but I see that many implement the crack, which is based on Creo. This is the same Creo as the technique for making snapshot, but they're making snapshot with only one process, and crack is able to basically you can snapshot JVM. I saw that the stuff is integrated, but it's not in the managed manner. So basically you start somewhere, then you make the snapshot of a Lambda function, and then you have the live Lambda function which starts from the snapshot. So a lot of manual stuff involved in this, which is of course not so good. I know that Google has, they have kind of something like on the Google functions like boost GPU. So you can in the cold start you can buy more CPU, sorry, cycle that will also give you more processing power. So this is how they attack. But Snapstart is of course purely AWS specific. I personally expect there will be more automation around Creo and Crack, or maybe more automation around Project Laden if it will be accessible to everyone. So then the cloud platforms will think that depending on what you can set there, that they will provide kind of then a managed version of this. Because I didn't mention this snapshotting, it has also its downsides, also with Crack, but also with Snapstart. You don't want probably your credentials to be snapshotted. It's the security risk, but there are also things that you probably don't want to use time-based caches. I don't use it. I recently used cache, but if you have time-based cache and you make a snapshot and then the value is allowed to be in the cache for 10 hours, then you do restore after 8 hours, the value is there. But if you restore after 11, the value is not there. So it impacts a bit of correctness of the program. And there are use cases kind of described how it works. Crack is not particularly good with open files or file handles, because if you just restore it, the handle is not there and all that stuff. So it has its downsides, but basically, if you are careful and read, then for many use cases, you can use that. But this is my answer. I think GraalVM native image is basically supported for everyone. And many cloud providers use containers beyond the functions like Kubernetes anyway. So you have there some possibilities. But I see a lot of around Crack, class data sharing, and the stuff that other cloud providers are currently dealing with.
In the beginning, you had the comparison of different languages and how Java is basically, that Python is basically very much killing it. At the same time, I've done in the newsletter the other day, I had a piece where it showed that like Python is the most ineffective compared in the programming language itself, like compared to Java, compared to C++. So do you think these things can even themselves out, or is it just that like if people go serverless, they go Python immediately because it's one of the cool new things?
We went with kind of Node.js TypeScript stuff. Of course, you need to look on the call starts, and they are with Node.js and Python maybe around 300 to 600 milliseconds, which is significantly lower due to the nature of that programming language. But of course, you need to look also into the warm starts, and they can be bigger. And then you need to compare if I have 98% only warm start, which is slower, and only 2% of the cases cold start, which is kind of quicker. It's not the easy question. Of course, I see a lot of people using Rust currently, and Lambda supports Rust because it's kind of very, very effective programming language. And I know, for example, that Lambda kind of as a platform, or the logic, how this container are placed, AWS rewrote many things from Java to Rust, because this piece should be very quick, because if that is slow, then I cannot have slower cold starts. Yeah, so everything under the needs should be at least as quick as possible. But of course, Rust is, I would say, many find it cool, but it brings me a bit to the times of C or C++ development. So this language, for me, it's not mature. It's not the same community current. It might be growing, but I really appreciate that there's so many open source projects that I need to generate PDF and all that stuff. I can find trustful open source project. I'm not quite sure that the Rust platform and the whole ecosystem provides like this. It's not only about providing, it's about constantly maintaining that stuff, fixing security problems. So it's not simply just take some language. We are doing so many things around that. So I think if companies are very proficient with programming language, have their knowledge, then sometimes if it's not exchange or gaming platform or bidding platform, sometimes just to stick with programming language of your choice where you're productive is a better choice over having maybe a bit higher call starts.
And there's also the financial support from big corporations like Oracle
yes,
and in this case Red Hat and others, basically that Rust doesn't have, coming from Mozilla and being in this like more like indie space originally. I mean, by now they're getting there, but it's really tricky. Now, Project Leiden, when you showed it, it was basically showing like by 8/8/23, which is kind of long gone. Do you think the delay is because of the corporate nature of it, or is it something that you think it's going to be hard to roll out that within the core of Java without breaking a lot of stuff out there?
I of course don't have insights behind the scenes, but the first 2 increments have been released in this summer, so we can already test. This is kind of betas, so they are doing this stuff, and I personally think it's quite interesting how it will be going. I think then we as a developers will have the choice, depending on the nature of application, serverless or not, to use different settings of this stuff. So currently it's a lot of around class data sharing, that more information will be put in class data sharing, which is available since Java 5, but not many people were and use that. I think they will go also into the direction of native image, like this GraalVM is as an option. Yeah, and then we will need to select what we would like to have, but all the settings will have probably some trade-offs or things that we need to do additionally and run our application. I think they would like to give the people the choice, but it will take time just to implement all that stuff. But I didn't try the first release. I only saw the presentation. I think it was Devox UK from people from Oracle. They presented the current state in May. And I saw the first release. I maybe would like to give it a try. But once again, without support of Lambda and Cloud and Azure functions in the proper way, it will be quite difficult to use on serverless. It might be easier maybe to use on the containers, where we have more possibilities to do the stuff because we are managing more. With Lambda, and it's very difficult if I need to store the results of after the several invocations. It involves a lot of hacks or environments where I start something, make then snapshots, and then put that live. I personally see a lot of more work involved if the cloud providers will not support like managed laden or certain configurations for me. But I'm currently maybe wrong on how it will be going. I hope that it will be good, because I think that the native support in the GDK itself is a big step. Yeah, not just trying to do things around GDK, but improve the GDK itself or provide capabilities. It's always kind of the best choice, especially if it comes from Oracle.
So you've done a ton of research into this. It must have taken a lot of time. Did you get that as a sponsorship from your employer, or did you do it in your free time?
It's to be honest, 100% my free time. But it just took months, years to do the stuff, to think about, got feedback or questions from somebody, how that might impact. So this is kind of constant collaboration. I'm collaborating with the AWS developer advocates with my results, but I'm not sponsored by somebody. I'm not triggered by somebody. It's completely intrinsic motivation.
Cool. Well, thanks very much. This was great. We have your details. If people have more questions, which they didn't ask right now, they can contact you. And I hope the video will be out soon, so we can actually read it up and probably watch it in details, because there was a lot of information for one talk. So, but
sorry if it was too quick. I wanted to pack as much as possible.
Are you in your kitchen? Because we heard like clinking in the side, like is somebody doing the dishes?
I'm in the kitchen, but it should be quiet. I have the dog here, and yeah.
Is it also a setup?
I have white Highland Terrier, so quite small one. Yeah.
Excellent. Well, thank you, Vadim, and I hope to hear from you soon. And the video will be out soon, and people have more questions then. It was great seeing you, and thank you very much.
Yeah, thanks, Chris. Thanks, Aisha, Frank, Vincent, for the invite. Bye.
You're welcome. Well, I guess that's it for Vadim's talk. We have another 2 minutes until we start with the next talk, but I don't think that's actually long enough to have a break. So I'm actually going to be annoying and put Aisha on stage and start talking to her without actually showing her slides yet. So Aisha, how are you doing?
I'm doing good, Chris. What about you?
I'm not bad. I'm the dog's whining and he wants to go out soon. So, but we have another hour to go, so she has to suffer through that, and then we go from there. So you're going to talk about making your Java code bug proof. How would I mean, without taking it, without giving anything away? Like, I mean, bug proof is an interesting concept. Is it like writing defensive code to make sure that you predict bugs, or what do you mean by that?
Actually, this is a tricky title because, disclaimer, you cannot write a program that's bug-proof 100%. Yeah,
Mhm.
but I will help you to create a defensive strategies to keep as much as possible bugs from your production.
Mhm.
I'll try to give you some introduction on and absolutely like because as a Java developer, one of our the best we say the bonus of Java is the error handling mechanism. Like we have the better mechanism. You can say other in any other programming languages. No offense.
Yeah.
So I want to others to really get to know it, how they can use it, how they can upgrade it to have less bugs, less frustrations, and let them code new features happily ever after.
Hmm. And I mean, Java developers are used to looking at stack traces and stuff. Whereas, like, I worked on the developer debugging tools in the browser in Edge, and it just fascinates me how JavaScript developers all use console log for erroring rather than just using breakpoints and actually looking at the trace. It has the same tools, but people don't take them on. They just basically write and change and write and change rather than looking at what happened. So it seems like the Java world is used to scrolling back in the terminal for hours on end to find the problem rather than like writing another message to tell them what the problem is.
Indeed, like we need to get used to effective communication, even with our programs.
Cool.
We need to listen to it.
So, quick one before you start. You have you're a women tech ambassador. How does that work right now? Is there a lot of insight and a lot of help with that? Because in the US, a lot of the like women in tech programs actually had their funding cut. Is it something that you have to worry about here as well?
Actually, sponsoring has been always the biggest struggle for us. Struggle, even as organizer or as a woman tech makers. But for us, as because Women Tech Makers is the initiative of Google, we got fundings on special events like International Women's Day or some campaign that when we have, for example, events that talking about technology that's created by Google, we can
Hmm.
ask for funds from the association to give it to us. So it's a big help for us,
Okay.
especially if we did some campaign, for example, for encouraging other women to go into tech, go into speaking in tech events. That's also help.
Hmm. All right. So not too bad then. That's good to hear because I'm very worried about that, basically that funding going away. So without further ado, as we're on time, so I'm going to hand over to Aisha Laifa. I hope that was right. Uh,
It's yeah, it is. I'll just tell you some fun facts. My name is Aisha, and my family name is Lafia. I'm Moroccan, and Lafia in Moroccan dialect means fire.
of course.
Yeah, that's why I add that logo.
Okay, excellent. So, well, then fire away and tell us about well, how to make our Java code bug proof. And I talk to you afterwards, and hopefully people have a lot of questions.
Me too. Like, I really hope this could be an interaction session, not just me talking.
Excellent. So, over to you.
Thank you all. So, good afternoon, everyone, and thank you to the last session on today's Java Days. Let's make your Java application or your Java code bug-proof. But before we jump in, let me introduce myself. My name is Aisha Lafia. I'm from Morocco, but currently living in France. A Java software engineer with a love for coding, a heart for volunteering, and a taste for delicious code. And food too. So, as a Java software engineer focusing on building resilient and maintainable backend systems, I'm more passionate about error handling because errors are part of our systems. Like we deal with it, we can say mostly daily. It's beside of my job, I'm also a member of many local international communities, such as Moroccan Association for Computing Science, where I'm wearing their t-shirt right now. I used to be community lead for BTEC MA and member right now for T-shirt France, Ladies Code, Paris, and more. And I'm also Women Tech Makers and Girls Code Ambassador. First thing we need to ask ourselves is why? Why am I doing this talk? Well, you need to know that error handling is just not a technical necessity, but a cornerstone of building resilient applications. Properly managing error, ensuring that our application can gracefully recover from exceptional situations, enhancing reliability, and, of course, having a better user experience. Fun fact, or not fun facts. Did you know that 70% of production failures are due to improper error handling? These statistics highlight the importance of a robust handling mechanism. So, for you guys, have you ever had a project breaks in the production because of improper error handling? I'd love to read from you, so tell us what's happening. And for today, we will explore how to effectively handle errors and prevent such issues from occurring. And here's what we will cover today. We will start with understanding Java errors, moving on to creating custom exception, exploring some error prevention strategies with effective login strategies. Also, we will check some debugging techniques. And finally, we will discuss a mindset shift toward embracing errors as opportunities with a case session, of course. So let's start. First, I would like to start with a little introduction about the different types of errors in Java, including checked exceptions and checked exceptions in error. Like each type play a crucial aspect on how we handle errors, and it's better for you guys to have this basic knowledge before we delve into more advanced concepts. So, first thing first, checked exceptions. You can think of it of these checked exceptions as Java's way of saying, hey, something could go wrong here, make sure you're ready for it. Like, these exceptions force you to either handle this issue right there or at least declare it could happen. It's all for keeping your code safer from unexpected crashes. Quick heads up. After a birthday trip to Disney Stars Worldland last weekend, I've been inspired, so from now on, all the demos or the codes are Star Wars themed. All I can say right now, by the force, be with our code. So, you can say that these are the Jedi Council of exceptions. You can ignore them, and they demand you to handle problems or declares at least in your code, as I said. In this demo, we will have a method called find hologram. It throws a find not found exception if it cannot locate the hologram file for a Jedi. So for the find not found exception is a checked exception that's already built in your Java core, meaning that Java force us or you can say it. We all force us all to handle it with a try with a catch risk block or declare it using throws here like this. Like declares on the middle signature, or you can use try, which try catch block like here or in the main. So let's run this for you though. But as you can imagine, Utah's holocron has been lost in time, so we should see something like this. The exception is triggered, and we need to get the message, for example, hologram for Jedi Yuda is not found. This is how checked exception force us to deal with these situations. And I'd like to hear from you. So, what's the weirdest checked exception you've ever had to handle? How did you deal with it? write us in the chat so I can read it later, because I'd love to hear from your experience. And moving on to the unchecked exceptions. You can tell they are like just a wild card of error handling because they just pop up when you least expect them, often due to some logical errors or some use of an API, for example. Well, Java doesn't like really force you to handle them, but they play a critical role in exposing hiding bugs in defeats in our code. So let's check. For example, we have a method called trainGDI. If you pass in a null, like here, a null pointer exception will throw. Unlike checked exception, you don't need to declare it in the method signature here. So let's run this and see what happened when you try to train nothing. Well, no GDI at all, no one assigned up. We got the message, you cannot train the air paddle, like no GDI assigned. And this is how an unchecked exception can catch you by surprise. Like, surprise, you did something wrong, please fix it. And that's it. This is how we can resume the unchecked exceptions. But the thing is that you can recover from. It will not like really crash your application. You can recover, that's good. Also, like, who has or had to deal with null pointer exception? This is one of the famous unchecked exception that each Java developer had to deal with it once or twice, you can say, in a week. So drop a quick yes in the chat if you ever have been dealt with null pointer exception this week. And finally, the heavyweights in world of Java problems. Ladies and gentlemen, the errors. As they indicate something, because they indicate something like seriously wrong with the environment which your application is running. Unlike exceptions, errors are not meant to be caught or handled because they usually point to conditions that the application cannot ever recover from, like running out of memory, for example. As you can see here, we can consider errors as the galactic catastrophes of the code world, usually the main things that have gone very, very wrong. So in this demo, we are simulating the out-of-memory errors by trying to allocate an enormous, a big array. We overload the system. This is like equivalent to trying to train every Jedi in the galaxy at once. So let's watch what happens when we go overboard with the force. Boom. The system crashes with out-of-memory error, like telling us application request array size exceeded the VM limits. And this is why errors are typically not something you can recover from easily. To recap, here is a quick guide on how and when we can use check different types of exceptions. Like checked exceptions are for expected recoverable conditions, while unchecked exceptions should be used for unexpected programming errors. Errors, on the other hand, are generally reserved for unrecoverable conditions that are beyond the application's control. Not handling these exceptions or errors properly can lead to severe consequences, including, like, for example, program crashes, data loss, which will result in a poor user experience. That means we will lose money too. And now that we have seen how different types of exceptions work in Java, like in a Java application, you might be wondering like how you can make error handling even more specific to your application's need. And that brings us to the next section, creating custom exceptions and designing meaningful exceptions hierarchies. Because we have seen how Java provides a range of built-in exceptions, and that I really suggest you to read about it, that all the exceptions are already built in, because sometimes we don't need to rehandle it manually by ourselves. That's why I'm always advise you guys to go to the basics of the Java course, read about exceptions, how to handle them, especially the list of the built-in exceptions. But all these exceptions sometimes are not enough. And to make our code more robust and expressive, we can create our custom exceptions. So instead of, as I said, relying on generic exceptions, which can be a little bit ambiguous, custom exception lets you define errors as that are, for example, specific to your domain. It's all about enhancing readability and manageability of your code, especially when working with, for example, complex or different, a lot of business logic. So for like we create custom exception, it's all about precision, readability, and maintainability. Because for the precision, sometimes custom exception allows you to precisely define errors conditions specific to your application. They also improve code readability by clearly stating the nature of the error, and that will also facilitate easier maintenance by organizing errors according to the business logic. Also, as I said, we need to ask yourself when to use custom exception. Well, first thing first, use when a generic exception doesn't fully convey the problem. If not, no need to like really do extra work. Also, when you need to encapsulate, for example, business logic validation failure, like if you're, for example, writing a code for an e-commerce application, you can write something like invalid order exception. And there are some situations when the same error condition occurs in multiple places. You don't need to repeat your code. So what you need is create a custom exception that will help for the reusability. And now I'd like to read or to hear from you. It's your turn. If you could invent a custom exception for your development frustration, what would you name it? Like, I'd like to read the funniest idea that you could think about of custom exception. And after that, let's check some demo for the custom exception. So in this demo, we will validate a JEDI's mission, making sure that it's approved by the JEDI Council and that they don't have too many tasks. As I said, I'm always going to stick with the Star Wars theme. So custom exception, for example, like the mission not approved exception and too many task exception, make it like really you can tell what exactly went wrong. Imagine if we try to figure out, for example, illegal state exception or exception meant in this context. You could not like really give clear idea of what you need to do to fix it. So it will not be even nearly as intuitive as this one for mission not approved exception and too many task exception. Let's try to run it and we will see what happened, for example, for Anakin trying to take one mission that has not been approved by the council and that has 5 tasks. It's too many for any Jedi to handle. And here we go. We get the message. Anakin's mission has not been approved by the council, a clearly specific error tailored to our scenario that we can really go through exactly know what went wrong and fix it without you can say taking much time to look for information. That can lead us to more being frustrated in these scenarios. And let's try even with, you can say, these custom exceptions. They are not enough because we need to upgrade our exception strategies by doing something that we call the best practices for exceptions hierarchies. Like designing meaningful exceptions hierarchies, it's all about organizing exceptions in a way that reflects the logical structure of your application. So by starting with the board-based classes and extending them in more specific exceptions or situations, this is where we talk about generalizations versus specializations. You can also handle errors in a consistent and organized manner, where you can use consistency in naming by using consistent naming convention that clearly states or indicates the nature of the exceptions. Also, you need to design your hierarchy to be more usable across the different model of your application. As I said before, no need to rewrite the same code in many places. And please document the hierarchy clearly. Explain when and where each exception should be used. Because this exception might be used by other person in your project that doesn't really understand the contextual or why we did create this. And this does not only make your code more maintainable, but also it allows you to implement, you can say, more sophisticated error handling strategies. And I would love to know from you, like, what's your approach and tips for keeping, for example, exception handling clean? Like, if there are some other exceptions hierarchy tips that I didn't mention, I'd love to read it from you. And moving to our demo. So as I said, now that we have seen how custom exception can make our error handling cleaner, let's take it to a step further by organizing these exceptions into hierarchy. Like in this way, we can handle, for example, different types of mission errors under one umbrella, the mission exception. The base class mission exception, like here, represents all the mission-related errors. While the child class is mission not approved, or exception or terminate task exception handles specific errors. In this way, we can catch all the mission errors under the mission exception type, or catch a specific exception as needed or as if it triggered. So let's run this for Leah. Her mission is approved, but she got like too much task on her plate with 5 tasks. Let's see. As expected, we got the error. Leah has too many tasks. So the force can only handle so much. And notice that how we can throw both exception within the same method, but still have the clarity on what exactly went wrong. This is why, like, I highlight or I love to do exception hierarchies because it's cleaner, more efficient, and it's making our life more easier to deal with bugs. And now this is where we shift from just reacting to errors to proactively designing our system to avoid them. We can say this is where the fun begins. So let's talk about error prevention strategies, starting with defensive programming. This approach is all about anticipating potential issues before they arise. Instead of just reacting to errors after they occur, defensive programming encourages us to think, for example, ahead and code in a way that prevents error from happening in the first time, as much as possible. So we can resume defensive programming in 3 words: anticipate, validate, and error handling. You need to anticipate potential issues in every aspect of your code. You need to validate the of the input and output to prevent unexpected errors. And you need to design error handling mechanism to catch issues earlier. So let's introduce our first strategy. Input validation, your first line of defense. You can think of it as the bouncer of your club. Its job to make sure that only the right data gets in, keeping the bad data out, like stop the bad data at the gate before it crashes your party. Just like a good bouncer preventing the troublemakers from causing chaos inside, proper input validation prevents common vulnerabilities like SQL injections, cross-site scripting, from wrecking code in your system. So, what's the craziest input in your system has or have ever to handle? Share with us a wide example. Let's see who had the most unexpected inputs. So let's start with, for example, a simple example of input validation. Here we are making sure that both the Jedi and the mission inputs are valid. If either one of them are null or empty, we throw illegal argument exception to stop the method before it can do any harms, like here. In this example, Yuda is assigned to a mission, but the mission details are missing. So let's see what happened when we run it. Then, as expected, we got the validation errors. Mission details missing, no mission, no adventure. And this is the first step in preventing bad data from causing problem later. So you can say once we've ensured that only the valid data is allowed in, the next step is checking precondition to guarantee that our methods are working with proper data. The preconditions, you can consider them like the final check before a skydriver jump out of a plane. Because just as you would not jump without making sure your parachute is properly packed, you should not ever run a code without confirming that all the necessary preconditions are met. Like you need to catch issues before they catch you. So by checking things like null value, system state, and input constraints upfront, you avoid unexpected errors that ensure that your code only runs when everything is in the right place. So if the input validation is the outer wall, the preconditions are the internal security checks, making sure that all the critical data is in the right place before any important logic is executed. Like for the null checks, you need to ensure your objects are not null before proceeding. Well, all this to avoid the null pointer exceptions. Like not today, not the day after. For the state validation, you need to verify that the system state meets all the required conditions before moving forward. And finally, for the input construct, you need to confirm that the input value meets all the necessary criteria, like no surprise are allowed. So for you guys, what's the one thing you always check for before running your code? Null values, empty conditions, share your number one. So in this small demo, we are adding preconditions that say Yuda should not handle temple defense alone. If Yuda is assigned to defense the temple, we throw an expected to prevent him from getting overwhelmed. Let's run this with Yuda, like here. Check the precondition here. So let's run this with Yuda on the temple defense duty. And as expected, the precondition kicks in and we got Yuda is too old to handle temple defense alone. And in this way, we prevent potential issues by ensuring key conditions are met before we move forward here. But even beyond the applications, input validation and precondition, there are a few more essential techniques we can apply to make our code more robust and resilient. That are the bound checking and resource management. Building resilient one check at one or one check at a time. Because defensive coding is about more than just avoiding null pointer. It's about ensuring that your code operates safely and efficiently, especially at the prod. Bound checking prevents your code from accessing out of range indices, like avoiding runtime errors and exceptions. Meanwhile, proper resource management, especially with tools like try with resources, ensuring that you are not leaking memory or leaving files open. And I really love to use try with resource. Like you can find this a lot in my code because you don't have like to really pay attention to each time if you forgot to add close, resource close, or you forgot, for example, to call or to end some memory leaks that could not be handled on the garbage collector. And yes, garbage collector is not guaranteed to work 100% on the Java cores. You need always to pay attention to the memory leaks, even in Java. So together, these practices form, we can say, a solid foundation for resilient, error-proof application. As you can see in the meme, what's more dangerous in your experience? Null values or out of bounds errors? Type null of or bounds. And please don't make your application run on file. This is like I really choose to do this meme because literally, if you skip, for example, try with resource, let one of the resources leaking some data behind, you will be working fine in your application, and at a specific moment you said your application is crashed and you don't know like really what went wrong. And let's see in more detail, like in this demo, we've been adding bounding check-in to ensure that the GDI's mission tasks are manageable. First, we validate the task list isn't empty, which will prevent issues before they start. Next, we will set in a limit. A GDI cannot handle more than 3 tasks, like here. Here, this one for the not empty or null. And after that, even if the force has its limits. This helps us to keep mission realistic and prevent our Jedi from getting overwhelmed. So let's run the code for Luke Skywalker, was assigned 3 critical tasks: destroying the Death Star, comforting Darth Vader, and escaping the Emperor. Everything works smoothly. That's good. Luke is on a mission to defeat the Empire. And it's done. Good for him. But what if we added, like, for example, a fourth mission? We ask Luke to deliver a talk, like here. Well, boom. The exception is triggered. Luke cannot handle more than 3 tasks at once. The force is not that strong. Unfortunately, he cannot give a talk. So this is how really defensive coding helps us anticipate and handle these edge cases. Like create a code that works fine in the capacity that we had for our systems or our, for example, hardware, software, whatever we were using. And now that we have built strong defenses, it's time to introduce another crucial aspect, which is logging that we talk about before we delve into our introduction with Chris. Effective logging is the heartbeat of your application. It gives you the visibility into what's happened, helps you diagnose issues, and even keep track of the performance over time. It's all about turning chaos into the clarity. Without proper logging, you're really flying blind, hoping nothing goes wrong. Like, but doesn't work because logs tracks key events in user action, helping you understand application flow. This is what we meant by event tracking, or the error diagnose. Like detailed logs really helps diagnose issues quickly by pointing the exact moment something went wrong. Like you stop guessing or wasting time checking each part of your code what went wrong. And of course, you can use logs to monitor performance over the time, identifying bottlenecks and optimizing efficiently. So what's your logging style? Are you the log everything or the log when necessary team? Type everything or necessary. Let's see whose team is winning. And to make, for example, login truly effective, we need to structure it properly because structured structured login transforms your logs from example chaotic mess into a treasure trove of actionable insights. By using tools like SL4G that offer a simple and unified login interface for various login frameworks, while Lookback is a robust login framework complement SL4G by providing powerful structured login capabilities. You can ensure your logs are consistent, including all the necessary contextual information and that are easy to search and analyze. You can use any tool you like. There are also the Elki Elasticsearch stack. That's that's actually one of my favorites. I used to work a lot on my previous projects, especially with cap, especially like with the dashboard. I can easily search either by starting to type the message of the errors, the name of the errors. I can find all the timeline on when this error have been occurred on different environments, and even if it's like occurring frequently or not, have been dealt with it on the previous. So this not only make it easier for diagnosing issues, but also helps in monitoring the overall health of your applications. So let's see how we can like add structured login to keep track of the GDI's mission in detail. This will give us like a really useful information when something goes wrong and help us see the full picture, what's happening on the GDI's Academy. So in this code, we've added informative logs on like at each key point. Like for example, here, this one for errors, starting missions, logger warm. Like when the mission is started, we log at the Jedi's name and the mission they are embarking on. If the console doesn't approve the mission, we log a warning with logger warm and let so. And if there is an error, we'll log with logger error, for example, mission failure due to with the error message. So let's run and see how login help us crack Luke's missions. We can log warning if the Jedi's Luke have been assigned too many tasks. And as you can see, the logs clearly show the mission initiation. Like starting mission for the Jedi, look on task, retrieve the Jedi's text. And there is an issue like look I've been assigned too many tasks on not getting approved from the console, the log will show it. Like for example, Jedi here, Jedi look is attempting too many tasks, which is 4, and the capacity is only 3. And the mission failed due to look to Jedi look has too many tasks assigned. So right now from the logs you can clearly go to the task number, change it or reduce it to 3, and everything will work fine. Instead just of investigating all the code to check what went wrong. And this is how logs like will really provide enough context for us understanding exactly what went wrong and helping us or saving us from wasting enormous time on debugging. And now that we have explored how effective login can give us deep insights into our application, let's talk about what happens when something does goes wrong despite all our best offers. Because nothing is perfect or bug-proof 100%, as I said. Debugging is an essential skill in the developer's toolkit. It's all about the ability to set breakpoints, step through code, and watch a variable in real time allows you to quickly identify and restart issues. Like for the breakpoints, you can pause code execution to inspect the state of your application. For the watch variable, you need to monitor variable changes in real time for deeper insights. Like you need to really what's went wrong on the exact moment. And for the conditional breakpoints, you can trigger some breakpoints based on specific conditions to isolate issues. Like you don't need to deal with all the method. You can just set some breakpoints on, for example, the if block code to check if it's working or not. So what's your preferred way to debug code? Type breakpoints, logs, or print statement, and let's see which methods win. So these basic debugging techniques, we can say, are incredibly effective at resolving common issues. And let's try to check, or let's begin by using the basic breakpoints to pause the program execution. In IntelliJ, well, this is the IDE I'm using right now. So I will be talking on some tips, tricks you can use to debug on IntelliJ. We can set breakpoints at the key points in the start mission method and the execution mission method. So to see, for example, how tasks are completed. Moving on, like for example, to keep track on the variable at programs run, we can add watches. Here we will try to monitor the task variable to see how it changed as you completed each task, for example. As I said, in IntelliJ, you need just to right-click the task variable and select Add to the watch, like here, to watches. And this will allow us to track the variable of the task throughout the execution, where you will see something like this. Like the variable, it will be at the sign of glasses. Here, this meant that task is being watched. And this will allow us like to really track the value of tasks throughout the execution in our real time. So let's run the code in the debug mode. The execution will pause when the user starts in his mission. And it will tell us, for example, here the task is 4 at that time. And as we will, like, for example, before Jada Yuda has started until he finished all his tasks. But we can say that even in more complex system, debugging become more challenging. For example, we are not dealing anymore with just a local environment or one mono-threaded application. But if we are dealing with concurrency or remote environments, it's been even more challenging to debug, especially using these techniques that I previously mentioned. So let's try to see how we can debug these advanced environments or problems. As I said, sometimes local debugging, it just doesn't cut it, especially when you're dealing with issues that only appear, for example, in staging environments, in dev environments that's related to another team, or in production. And this is where we need to call our superhero, or I should call it super remote. The remote debugging allows you to connect your IDE to a remote application, giving you the ability to diagnose and fix issues as they are happening in front of you, as you are like really working on your local environment. And when it's come to concurrency, advanced debugging tools are essential for tracking down tricky issues like race conditions and deadlocks. And you can use breakpoints in concurrency. Like for example, set a breakpoints within multi-threaded code to observe interaction between threads and more. So, has anyone here had to debug a concurrency issue? How did you solve it? Share your biggest debugging challenges. Because as a Java developer, we have always the concurrency have been the bottleneck, like the most frustrated issues we have to deal with it. Even with all the future that we've got with the multi-threads, it will be even more occurrent to face this type of errors. And this is why you need to master debugging concurrency using thread inspections and the breakpoints in concurrency. And this is where let's see some, for example, a code to demonstrate how we can do it. So here both Luke and Leah are working on separate missions, each running like in their own thread, in their own world. We'll be using intelligent thread debugging tools to track the execution of both missions at the same time. You can see that which parts of the code each thread is running and switch between them to inspect what's happening. So in IntelliJ, you need to just only go to View, Tool Windows, Debug, and you will find the threads like this here. Wait, sorry. Threads here. This one. So here you can see both Luke and Leah's thread. You can inspect and switch between the threads. So we will set a breakpoint inside each of the Jedi's mission and use the thread debugging feature to switch between Luke and Leah's as they complete their task. When we run the code and observe how Luke and Leah works through their mission, we'll switch between their trees in real life to see what's like how they're progressing with their mission. We will show something like this, like the tree, which tree is working on, and like for example, the data progressing, the workflow, and more. And by the end, we will get something like this as a result for our code. This is will showcase that the trees doesn't work, for example, at the same capacity or at the same order, and we can like really see how it's work on the real time if we went to treat in variable during the process time. And now it's time to move from something technical to something we can say it's really helping us in our mindset. So as we come to the final stage of our journey, it's important to talk about mindset. How we handle errors and failures can have a huge impact on our growth as a developers, especially because we are human after all. We need to know how to deal with it in the more efficient way. So first thing you need to accept is that errors are inevitable in software development. They always exist. However, how we perceive and approach these failures and errors can make a significant difference. Shifting our mindset involves embracing failure as a valuable learning opportunities rather than failure or something that's really bad, because they provide us with a valuable feedback that guides us toward continuous improvement. So when we view errors as a learning opportunities, we can extract valuable insight from them because errors are everywhere. That means opportunities are everywhere. Each error presents a chance to identify weakness, analyze root causes, and discover areas of improvement in our code and processes. So by embracing errors as a part of the learning journey, we foster a culture of the continuous improvement. And that's really good for us as a developers. Also, taking a proactive and a growth-oriented approach to error handling brings several benefits. It allows us to identify and address potential issues before they escalate, resulting in more stable and reliable software, which lead to a better user experience and more profits. But when we're talking about the money, it also encourages collaboration as because team members can learn from each other's experience and collectively strive for excellence. And it's a great way to keep the office coffee machines conversations interesting, as we all learn from each other's epic coding mishaps. And mostly it's funny, like when we talk about errors we had, how to deal with it. Sometimes someone already had seen how to work with this kind of errors. Others might suggest more efficient or optimized way to handle it, and more. So teamworks make the dream works. And finally, by embracing errors as opportunities for growth, we foster an an environmental place of continuous improvement and innovation. We become more open to experiment with new ideas, technologies, and methodologies. Like this mindset shift empower us to push boundaries, explore creative solutions, and evaluate the quality of our software applications and developments. And remember, embracing errors does not mean we create a bug museum or we get be proud of how much errors we get. It's about finding an innovative way to keep our code clean, and we can say our office walls free from squished insects. So keep clean code everywhere. And if you think that we are done, here is the bonus. As a Formula One fan, big fan, let's try to draw a parallel between error handling in software development and the mindset of the Formula One drivers. Because I've been a Formula One since 29, and I've become a Java software engineer at 20, you can say 2015, where I started to study software engineering. I have seen like a really parallel, like something we can learn from Formula One that helped me as a Java developer, especially in the error handling, because Formula One drivers are known for their ability to stay calm, focused, and collaborative in the high pressure situation. We're talking about situations that need to be handled in the milliseconds, not only seconds. And we can learn a valuable lesson from them when it comes to resolving errors effectively and quickly. As I said, it's important of staying calm and focused. Just as the Formula One drivers, software and developers need to stay calm and focused when faced with errors. Panicking or becoming overwhelmed can hinder our abilities to analyze and to address the exact issues effectively. So, by maintaining composure, we can think clearly and make rational decisions. Also, Formula One teams exemplify the power of collaboration in error resolution. Like they work together, pulling their expertise and the resources to find solution quickly. And now I'm not talking about the Ferrari strategy team. They don't do this. So, in software development, fostering a collaborative environment it really encourages the knowledge sharing, peer review, and effective communication, like enabling us to tackle errors more efficient, more collaborative, and quickly. Also, Formula One drivers follow certain practice to resolve issue effectively, and we can apply these steps to our error handling processes and software development. Starting with analyze the situation. You need to understand the root causes and gather as much as you can of relevant information. Know what went wrong. Second thing is communicate effectively. Share information with team members and stakeholders to ensure common understanding. Like everyone needs to be ahead of the situation. Moving to adapt and iterate. Be flexible in finding solutions and iterate, and of course, always iterate based on the feedback and the results. And finally, learn from mistakes. Reflect on errors and implement corrective measure to avoid similar issues in the future. Please learn from mistake. You don't need to handle the same mistake over and over each time it occurs. And now it's time to say thank you all for joining us, and let's drive error handling to success together. Feel free to ask questions on the chat, and you can also scan the QR code if you want to contact me. You can also contact me via Twitter or LinkedIn. And you can read more on this article that's here. And let's go back to Chris.
Hey, well, thank you very much. This was great. Lots and lots of details there. I'm always fascinated of how much these Chrome-generated QR codes have in there. I mean, the data could be half the size. I don't know what else these points are, but the same with like Edge generated there. It's really bizarre. So I loved how you actually went through all the bits and actually gave it a theme that is probably copyrighted, but we won't be naming these names again. So one question I got in here is like, is there any chance of introducing pointers into Java, or is this not a thing that you might be going? But I don't know if that's actually for you to answer because you're not working on the language itself.
Indeed. But I don't think, because pointer normally it's work fine with the language that doesn't work with the objects. Because when we're talking about objects and references, they're already pointing to some places in data, in the memory. So I don't think there is, like, you will only repeat, for example, the mechanism that already exists in Java.
Mm-hmm.
I prefer someone from Oracle that could really get like good information about this.
Maybe we get one for the next Java Live Day. So we'll see from there, Java Dev Live Day.
Yeah.
One of the things that I find always fascinating, what do you think are the hardest bugs to spot? Like, what are the things that really drive you crazy and you had to apply several ways to actually find the problem? What are the things that people should look out for? What is the easiest way to spot something that feels like it's not there, but there is a bug?
It's the simplest yet hard to get. It's about mispronunciation or miscalling some function.
Mm-hmm.
Because you think that you called the right function, you check the function is working fine, then you find yourself calling some function with the same name, but it's in another, for example, package. So you need to pay attention to the import class you called.
Cool.
Sometimes you import the wrong class.
Yeah, I mean especially, I mean, we have the same problem in JavaScript that people use npm packages that then have other dependencies and then have other dependencies. So it's not your code, but it's the code from another package that might interfere, overwrites bits of yours. So that's the problem that I always find, that like, where do you go down the dependency chain to see where the error really occurred?
Indeed, it's exactly as Java, because sometimes especially when you are working with the IO that suggests you a quick fix import, and you don't really pay attention on which method you imported, and you check the results, something went wrong, this is not expected result, you go check the method, the call, everything's working fine. Until you check the import, you say yourself, for example, you imported from, for example, a call instead of b call package, something like that.
Cool. Well, you're kind of breaking up, so the connectivity seems to have some issues. So I think we're going to be leaving you in the wild now to spread your fire there. And people can reach you on Twitter and can actually see the video later on as well. Are you going to make the slides available somewhere as well, or are they already available somewhere?
I will share it with you. Okay.
All right, so we can add them to the recording then later on so people can download them there as well, because that's always the first thing that people want to have. And you've done a great job with them. So I'm really excited about going through them bit by bit as well. So I have more time on it.
Okay, I will share it. Actually, because I've been using Canva, let us share a link for it.
All right, as said, you are quite delaying right now. So there seems to be your picture is frozen. Hopefully it's yours, not mine. I guess that's all we got time for you. So thanks again, Aisha. And I hope to see you soon. And I hope to see you at the Congress speaking as well.
I hope that too. It was really a pleasure to talk here about Java, especially error handling. So thank you all, and I hope you enjoyed my talk. I tried to make it as fun as possible, and see you next time.
See you soon.
Bye.
Bye-bye. Well, and that was it. That is the Java Dev Day, the live day. We're done today. Next Wednesday, we're back with the Web Development Day. So we got a stellar lineup for that one. And the more interesting bit is that also we changed this format of these live days a bit more. So we make them more interactive. So you might have heard about Code 100, which is the coding competition that we had at the Congress, at the World Congress as well. And instead of going to different locations this year, we're going to have a Code 100 competition at every live day. So you get a chance to actually do a test in between, or to do a coding exercise and send us your results. And both of these winners will then get invited to the final at the Congress next year in July. So it's actually worthwhile coming next Wednesday, even if you're not a front-end person. There's going to be an agenda when we're going to give the challenges out, so you can actually start contributing to that one. So you're not only learning things, you're not only watching videos, but you're actually contributing to it as well. And you can become a Code 100 champion just by joining one of the WeAreDevelopers live days. So I see you next Wednesday for the Web Dev Day. There I'm going to be in Vienna in person rather than here in Berlin. And hopefully you learned something in Java today. And I hope to see you all soon. So that was it from us. Thank you very much. And look around the WeAreDevelopers website. There's much more to actually explore. Lots of Java videos from the Congress that I just uploaded. And let's learn some more. Thank you very much.